Pathfinder carried Sojourner millions of kilometers through space, relayed human commands to the rover, and then took pictures as Sojourner rolled onto the surface of Mars. In honor of another space pioneer, the US Space Agency has renamed Pathfinder for Carl Sagan. He was an astronomer who specialized in making it easier for many of us to understand space. Sagan died in December, shortly after Pathfinder took off for Mars.
Die Pathfinder-Mission zu unserem roten Nachbarn, ein Projekt zwischen Bang und Jubeln. Zwar ist die Sonde längst auf dem Mars gelandet, doch bislang machten technische Schwierigkeiten den Wissenschaftlern zu schaffen. Das Marsmobil wollte nicht so wie die Wissenschaftler. Erst klemmte es, dann herrschte Funkstille. Doch jetzt ist alles gut, der Robotwagen rollt durch den Marsstaub.
Und er bewegt sich doch. Mars Rover Sojourner rollt auf die Oberfläche des roten Planeten. Jubel im NASA-Kontrollzentrum im kalifornischen Pasadena. Um 6 Uhr mitteleuropäischer Zeit trat Flugdirektor Chris Salvo vor die Presse. Der Rover ist auf der Marsoberfläche und macht seine erste Fahrt, verkündete er sichtlich erleichtert. Hinter Salvo und seinen Wissenschaftlern liegen stressreiche Stunden. Zunächst hatte ein nicht zusammengefalteter Prallsack ein Ausklappen der Rampe des Marsmobils verhindert. Dann brach der Funkkontakt ab. Offenbar wegen eines Softwarefehlers im Bordcomputer der Sonde. In den nächsten Wochen wird Sojourner die Marsoberfläche untersuchen. In einem Umkreis von etwa 30 Kilometern um den Landeplatz. Besonderes Interesse richten die Raumforscher auf unterschiedlich gefärbte Steinbrocken. Sie sollen Aufschluss über verschiedene Entwicklungsstufen des Mars geben.
Guten Tag, meine Damen und Herren. Die spektakuläre Erkundung des Planeten Mars mit Hilfe eines kleinen Fahrzeugs hat begonnen. Nachdem einige technische Probleme gelöst werden konnten, setzte sich das Roboterfahrzeug Sojourner heute früh in Bewegung. Es soll Gesteine und Sand in seinem Umfeld erkunden. Die amerikanische Marssonde war am Freitag auf dem roten Planeten gelandet und hatte eine Serie gestochen scharfer Farbfotos übermittelt.
Aus dem Jubeln kommen die NASA-Wissenschaftler nicht mehr raus. Die neuesten Bilder vom Mars zeigen, wie das winzige Roboterfahrzeug Sojourner auf die Marsoberfläche rollte und damit doch Befehlen folgte, die von der fernen Erde kamen. Gestern musste die NASA noch bangen, denn zunächst empfing der kleine Roboter keine vollständigen Signale. Warum, weiß die NASA nicht, auch nicht, wieso die Kommunikation jetzt klappt. Die wirklichen Helden des Tages sind die Jungs, die seit Samstag rund um die Uhr geschuftet haben, um unsere Verbindung wiederherzustellen und damit die Fortsetzung unserer Mars-Mission zu ermöglichen. Der ferngesteuerte Roboter soll eine Woche lang sich von der Pathfinder-Sonde entfernen und in ein nach Expertenmeinung enorm interessantes Gebiet dringen. Zuerst gilt es, den Sand unter der Landestelle zu untersuchen. Anschließend fährt Sojourner zu größeren Gesteinsbrocken. Ein in Deutschland entwickeltes Spektrometer wird sich an die Proben pressen.
It was one short roll for the rover, but a giant leap for mankind. The rover, called Sojourner, inched its way onto the surface of Mars, becoming the first mobile vehicle ever on another planet. As CNN's John Zarella reports, the journey ended a frantic struggle to correct communications problems with the craft.
Sojourner has landed. For the first time in human history, an autonomous vehicle is on the surface of another world.
The images that you've seen today show a completely deployed rover that has driven down a perfectly deployed ramp and gotten to the surface of Mars, making its first tracks in the soil of this new planet.
Just as the Martian day was winding down, engineers at NASA's Jet Propulsion Laboratory received the first images of the 6-wheeled rover driving down a ramp and onto Mars.
There it is. Rover, don't forget to call home occasionally.
For the scientists on the team, seeing Sojourner on the ground is a great relief. Now they just have to decide what to look at first.
We have a whole variety of different things. We're already seeing differences in colors, in textures. There looks like there's layering in some rocks. There's that one flat-topped rock, and what are those? We gotta go see them.
It was the culmination of a roller coaster day of anxiety and excitement. Mission engineers spent much of Saturday trying to figure out why the rover and the lander were having a problem communicating. They sent new commands and waited for the response.
We have rover data. Yeah!
Working through the communications problem made it possible to deploy the rover. At one Saturday briefing, members of the science team acted like proud new parents. They unfurled a panoramic picture of the Martian surface. It had taken 5 hours to assemble the 120 tile-shaped images. It was okay to be upbeat. The mission is back on track. 120 million miles away, history is made 2 days in a row. For this team of engineers and scientists, that will be tough to top. John Zarella, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
This programming note, NASA is expected to give an update on Pathfinder's mission in about 2.5 hours from now. We're going to bring that to you live when it happens.
Mr. Golden, good morning, welcome.
Good morning, and what a great morning it is, Tim.
Well, let's talk about that and show you some pictures. This is the rover as it exited down its ramp, leaving its base. It's now about 4 feet away from its central base there. Can we expect Rover to rove around Mars today?
Yes, I believe that will be the case, and in fact, the scientists are busy picking the first target, and as they say, we're in a target-rich environment.
How long will Rover be on Mars today, and will we be hearing communications, and will we be seeing pictures today?
Well, Earthrise occurs on Mars at about 11 o'clock, so we'll start getting signals at that point. And sunrise on Mars is about 2 o'clock in the afternoon Pacific Standard Time.
So all communications have been reestablished and everything is 100%?
We think we're on target, and in space you never know what you don't know, but we have the brilliant young engineers here, and they'll pull us through it.
Mr. Golden, let me ask you a serious question. Based on what you have seen and studied so far, do you believe that there is life on Mars or has ever been life on Mars?
We have clues that indicate there might have been fossilized life on Mars. And by life, I'm not talking about little green men and women. I'm talking about bacteria-sized life. We have a very good sense that there could be life, but we won't know for a while. We have to get some more scientific results of the Mars rock, and we have to get some results back from a whole series of 10 missions over the next decade. We'll find that out, and we'll be able to tell America and the rest of the world for sure.
What about little green men and women? Any chance?
I don't think we'll see it on Mars. Maybe some other places.
In Roswell, New Mexico, this very same weekend, ironically, thousands of Americans joined together to talk about an alleged UFO that slammed into the ground there, and aliens arrived on Earth. As head of NASA, do you have any evidence whatsoever that so-called aliens have ever landed on Earth?
No, we don't have any hard evidence, but as scientists, we maintain the premise, we don't know what we don't know, and we'll be non-judgmental. If we see any data, we'll be the first to share it with America.
Do you believe in UFOs?
I don't know what I don't know, Tim, and when I see data, I'll be ready to say I believe in them.
But you don't rule it out?
I don't rule out anything.
Let me talk about Mir, the space station now in space, joint enterprise of the U.S. and Russia. Some real difficulties, as you know, since February, some major catastrophes, fires and losing compression. Is the American astronaut, Michael Foale, in any danger in Mir as we speak?
Safety is our #1 approach at NASA, and we're working very closely with the Russians. I want to point out that Mir has traveled almost 2 billion miles, and it's been up there for 11 years. There hasn't been one fatality. Russia and America will do whatever it takes to maintain the safety of Michael Foale and the 2 Russian cosmonauts. At the present time, we don't believe there's any safety problem, but I also would like you to know that we have 2 internal NASA teams and an external team led by General Thomas Stafford, an American astronaut who no longer works for NASA, to oversee this and work with the Russians to assure that people have confidence in the safety of that station.
The astronaut who preceded Mr. Foale on the Mir, the American astronaut Jerry Leninger, said that the problem with the Mir is that it was scheduled to fly for 5 years. It's now going on 11 years. And we really, really should get our astronaut out of there and ground Mir forever.
I'm not sure that Jerry said it in those words, but let me once again say that this is a very important, valuable experience. We're designing the International Space Station, and because of the experiences we've had on Mir, it is going to be a much safer space station, and we'll be able to really have a much higher confidence level in it. But let me once again say that we will never knowingly risk the life of an American astronaut or a Russian cosmonaut, and we have the appropriate safeguards in place to do that. But I also want to point out the space frontier is dangerous, and you could never get a 100% guarantee. But we're on the right track now.
The Russians are about to undertake what many, including your own people, have described as a very risky mission, putting themselves in spacesuits and trying to make some repairs within the spacecraft. If those two cosmonauts were American astronauts, members of NASA, would you let them undertake that kind of mission?
I'd have to be sure we understand it, but let me tell you, we have an American team in Russia right now working with the Russians on preparing it. That particular mission will not be undertaken till there's a confidence level that we really understand how to do it. They're running simulations in a water tank in Russia as we speak today, and we're going to be sure that there's the appropriate training of the astronauts in space, and more than ever, we want to make sure that they're rested.
As you know, any American research for medical or scientific reasons has been pretty well lost because of the part of the spacecraft that Michael Foale's records were kept has been sealed off. Why not bring the American astronaut home now?
Well, we believe it's still safe to be up there, and there are two issues that one has relative to keeping an American on that station. A, is it safe? That's the predominant, and B, is it productive? We have a team of people looking at it right now, and we're going to have to make a decision before September when we would have to bring up the shuttle to bring Michael Foale back to see if we'd put Wendy Lawrence, the next scheduled astronaut. If we don't believe it's going to be productive, it would be inappropriate to have Wendy up there because you just wouldn't send someone up there to sit on a space station and not be productive. I believe we'll have the right decision, and let's wait till a team of experts looks at it and assures that we're doing the right thing.
But as of now, there's real doubt as to whether or not you replace Michael Foale with another American astronaut.
I wouldn't call it doubt. I'd call it the scientific process. We have the best experts in the world working with our Russian partners to try and decide what is the right thing to do with regards to safety and productivity in space.
Mr. Golden, as you know, we spend about $14 billion a year on our space program. Tell the American people, other than the extraordinary, striking, pretty pictures we're seeing from Mars, why spend billions of dollars going to Mars or the moon or wherever?
Because NASA does things that no one else in America does. We look out 10, 20, 30 years. NASA, because we take on such tough missions, develops technologies that will impact the future generations of this country. We're rewriting physics and chemistry and biology textbooks that will change the way we conduct our lives 20 years from now. Going to Mars helps us understand how did life form? Are we alone? It helps us understand the climate on Mars, and it'll better help us understand the forces of nature on Earth so we could protect ourselves against changes from nature. It helps us understand how to develop new design tools so we could build better cars and automobiles. It helps us understand the evolution of life so we could protect the human species. But most importantly, it stirs our hearts. Never forget, America's a nation of explorers. I believe that we have exploration written into our genetic code in America. The boundary now is on Mars and the moon and other planets. We've developed an understanding of our own planet. We have to stir the minds and hearts of our young people so they'll lead the world in the 21st century.
Before we go, our next guest, John Glenn, was one of those young pioneers, the first American to orbit the Earth. He is thinking at the age of 75 of going back into space. You have room for him in your program?
I want to tell you, John is an outstanding astronaut and a great American. He has a burning desire to go back into space, and we're giving it very serious consideration, and we'll see where this goes. But he asked a legitimate question, and we got to give him a legitimate answer.
Daniel Golden from Pasadena, California, thanks very much, and we'll be talking to you throughout the week as pictures from Mars continue to return here on Earth.
Entdeckungsreise. Zum ersten Mal in der Geschichte der Raumfahrt erkundet ein Roboterfahrzeug den Mars. Nach anfänglichen Schwierigkeiten hat sich das Marsmobil Sojourner heute Morgen um kurz vor 8 in Bewegung gesetzt, um seine nähere Umgebung zu erkunden. Die Wissenschaftler hatten in der vergangenen Nacht fieberhaft gearbeitet und ein Kommunikationsproblem zwischen dem Marsmobil und der Muttersonde Pathfinder gelöst. Über die erste Schnüffelfahrt auf dem Mars berichtet Anna Skibowski.
Die ersten Fahrversuche auf dem Mars liefen so reibungslos wie bei diesem Versuch auf der Erde. NASA-Forscher bekamen dann heute früh diese spektakulären Bilder zur Erde gefunkt. Mit maximal 40 Zentimetern in der Minute rollte Sojourner von der Muttersonde Pathfinder auf die Marsoberfläche. Für diese wahrhaft außerirdische Leistung ließen sich die Wissenschaftler dann auch ausgiebig feiern. Schauen Sie sich diese ausgelassene Meute an. Das sind die wahren Helden des Tages. Sie haben die ganze Nacht gearbeitet und alle Probleme in den Griff bekommen. Direkt neben der Sonde wird der nur 60 Zentimeter lange Roboter als erstes den roten Marssand untersuchen. Und in den nächsten Tagen ist dann eine Fahrt zur Erforschung dieses Felsbrockens und 90 weiterer Gesteinsarten geplant. Eins der wichtigsten Instrumente dafür ist die Kamera des Mobils. Und deren Innenleben wurde am Max-Planck-Institut im niedersächsischen Lindau entwickelt.
In der Kamera sind Filter drin, da kann ich in verschiedenen Farben auf dem Mars hingucken und daraus kann man dann rausfinden, aus was für Materialien die Steine oder auch der Sand auf dem Mars eigentlich bestehen.
Dadurch soll vor allem die Vergangenheit des roten Planetens entschlüsselt werden. Denn die Forscher vermuten rund um den Landeplatz von Pathfinder Gestein, das fast 4 Milliarden Jahre alt ist. In dieser Zeit hatten sich erste Lebensformen auf der Erde entwickelt und vielleicht auch auf dem Mars.
Gleich weiter zu Christoph Lang nach Pasadena. Christoph, auch wenn es für uns Laien vielleicht so aussieht, die Wissenschaftler haben den Landeplatz für die Sonde ja nicht zufällig ausgesucht. Was macht gerade diesen Ort so spannend?
Der ist deshalb so spannend, weil die Forscher glauben, dass hier vor Milliarden von Jahren gewaltige Wassermassen durchgeflossen sind. Und das würde bedeuten, dass der Mars damals der Erde sehr viel ähnlicher war, als es heute ist. Und schon jetzt spricht einiges für diese Hypothese. Denn die ersten Fotos zeigen, dass es hier sehr verschiedene Gesteinsarten gibt, so als ob sie angeschwemmt worden wären. Und dass es schräge Schichtungen gibt, so als ob alles unter dem Druck von Wasser entstanden ist. Das alles soll in den nächsten Tagen und Wochen untersucht werden. Und vor allem auch ein ganz seltsames Ding, wahrscheinlich ein Stein, von dem ein NASA-Experte im Spaß sagte, das sieht aus, als ob irgendjemand hier ein Sofa abgestellt hat.
Das wird sicherlich noch spannend. Wie schwierig ist es eigentlich, ein Fahrzeug zu steuern, das 500 Millionen Kilometer von der Erde entfernt ist?
Das ist relativ kompliziert, weil man sich es ungefähr so vorstellen muss, als ob man mit geschlossenen Augen ein Auto in eine Garage manövrieren wollte. Denn die NASA-Experten sehen natürlich nicht, wo das kleine Marsmobil hinfährt. Sie können ihm nur vorher sagen, wo es ungefähr hinfahren soll, und das tut es dann vollautomatisch. Und nach vielen Stunden sendet es dann seine Daten zurück zur Erde. Und dann können sich die Forscher so ungefähr ausrechnen, wo es wirklich steht und wie die Reise am nächsten Tag weitergehen soll. Das ist natürlich ziemlich mühsam, aber doch irgendwie spannend.
Dankeschön, Christoph Lang, für diese Informationen.
Hello, I'm Kathleen Kennedy at the CNN Center in Atlanta. We're waiting for NASA to begin its briefing on the latest from Mars. Meantime, this was the scene about 11 hours ago at the Jet Propulsion Laboratory as Sojourner made its first tracks on Mars.
There it is.
The rover's deployment capped off a very tense day at the NASA laboratory. The rollout was delayed by about a day due to a slight landing complication and to communication problems between it and Pathfinder, the main lander. But NASA officials say Sojourner's success puts them a step closer to putting footsteps on Mars.
We will send people to Mars when it's scientifically appropriate, when we could figure out how to do it for a reasonable amount of money because there are other problems inside the nation, when it's safe to go because the International Space Station...
When could you go? If all the money were there, if the will were there, when could you go?
I would say that the first decade of the next century might be possible.
NASA officials were to decide this morning what to tell the little explorer to do next. And for more on that, let's join CNN's Jim Hill, who is standing by at the Jet Propulsion Lab in Pasadena, California. Jim, I can only imagine what the mood was at NASA when they got the wheels in motion. Tell us a little bit about that.
Well, that's right, Kathleen. It's nighttime on Mars right now, and the rover has been sleeping, if you will, right down at the bottom of the exit ramp from the Pathfinder itself. It's on the surface of Mars, and before it went to bed last night, it took its little metal nose and poked it around the ground, and presumably now has information, analytical information about the geology of the Martian soil somewhere in its memory bank. Now, later on today, about 5 hours from now, scientists will have an opportunity to downlink that information, and that will give them their first actual hands-on information about the geology of the Martian soil. Also today, they're going to take the rover and give it an order to go to its next target. They've already picked that out. It's a rock that's just next to the rover right now. It's nicknamed actually Barnacle Bill the Rock, and the rover will walk up or crawl up to that rock and put its little metal nose against it. We can show you how that happens. If we can zoom in now on the life-size model of the rover we have here, on the end facing us, you can see the round metal nose-like object. That is the alpha proton X-ray spectrometer. Kind of a mouthful, but what that does is it moves against an object, literally touches it, and then fires off protons. And how those protons are absorbed by the rock or how they're bounced back and so forth can give scientists an absolute wealth of information about the composition of the rocks. So it appears that Barnacle Bill the Rock is going to be the first target that the rover does this with. And tomorrow sometime, probably tomorrow afternoon, the scientists will downlink that information. It has to be done in this way because the Pathfinder and the rover only operate during the daylight hours on Mars. Sunrise on Mars happens about 2 o'clock Pacific time today, and that's necessary to fire up the solar panels and so forth and get the day's mission underway. It's also necessary for establishing a signal to downlink the information that's in the memory now that was picked up yesterday. So this will be a very interesting day, Kathleen, from a scientific point of view.
So what can they learn from the size and shapes of the rocks that we've seen in some of these pictures?
Mars is interesting to the geologists because, unlike Earth, the rocks on Mars are thought to be, or have been, undisturbed ever since they were formed. Now, on Earth, we have a lot of processes such as wind, rain, ice, snow, earthquakes, the oceans, and all kinds of movement of geological plates that disturb rocks from their natural state when they were formed. Scientists believe that on Mars, none of this has ever taken place, and that the rocks that are now on Mars are very much in the same positions and very much unchanged from what they were eons ago when they were formed. So presumably that means that if you can analyze that rock, you have essentially a textbook of information about the history of Mars. And geology is all about reading the textbook of information contained inside rocks and soil. So the scientists think that they have a very thick textbook of information waiting for them on Mars, and that's why it's going to be so interesting to them to analyze these rocks.
Jim, we also saw some mountains in the distance. First of all, how far away are those, and what can we learn from those?
Well, the mountains that you're talking about are about 20 miles away. The most interesting mountains that they've seen so far are twin peaks. They look a little bit like the humps on a camel, so to speak. And how these formed, why they formed, and what they're composed of is of great interest to the scientists because as you look around the Martian surface, it does look very bleak and barren and flat for the most part. But when you see a large object like that, then something very powerful and something very significant, obviously, took place to form that. So they really want to get over there and examine that, but it's 20 miles away. The rover, from what I understand, can go out 100 yards or so, but a 20-mile trek is probably not possible. But nonetheless, by looking at these photographs and also by looking at information about the rocks that are actually in the area right around the rover, they may be able to piece together information about what those mountain peaks are and how they got there.
All right, Jim, I know you want to get into the NASA briefing, which we're told is beginning right now at the Jet Propulsion Lab. Let's listen in. They're introducing the scientists who are about to speak.
Well, good morning. It's been quite a day for us, as you all know. We have a fully functional spacecraft on the surface of Mars, and we have fully functional instruments in every regard. And as you all know, we have a fully functional rover as well. We were here until about 3 a.m. last night doing the necessary planning in the cycle for deciding what to do on Sol 3 on Mars, which occurs later today. And I'll give you some idea of what those things were. The rover basically is off the pedal. As you are all aware, we sent the command to deploy the IMP after it took a complete panorama in a variety of colors, our so-called insurance panorama, but we did not have confirmation of that until the next downlink, which would occur between 2 to 3 p.m. this afternoon. We have gotten data from the alpha proton X-ray spectrometer, and that instrument appears to be functioning just fine. So now we have data from all the instruments and all the imagers, and everything is working just perfectly. Our plans for today on the surface of Mars are to take our affectionately known monster pan. This panorama is a left-right red stereo pan, which is used primarily as a planning tool for the scientists to decide, finally stereo, so we can measure distances to things and sizes and start giving you some idea of where things are out in the scene and how large they are. But in addition, it's a primary planning tool for the rover. The rover needs this left-right stereo data to ascertain exactly where it is in the scene and to plan its next traverse. And the idea here is to get that down in 360 degrees as quickly as we can so that the rover can put on the stereo goggles and see exactly where they can and cannot go. They plan the paths using this stereo panorama. In addition to the left-right red, we also get a variety of other spectral filters. The idea is to begin to ascertain the colors and some of the spectra of the rocks out in the entire field. We made a decision last night on where to send the rover for Sol 3, and we have decided to attempt to send it to a rock affectionately known as Barnacle Bill. This rock happens to be quite close to the rover, will require a simple turn in place about 70 degrees or so, and a backup motion with the APX down to try to place the alpha proton X-ray spectrometer against this rock. We expect to get confirmation of deployment of the IMP and send up the uplink for the variety of commands that we've been working on through the night at about 2 or 3 p.m. this afternoon, and the main downlink occurs much later after 9 p.m. this evening. The very good news for the scientists here and all of us is that we have decided to double our data rate. We will be returning data at a rate of about 8 kilobits per second, which is unprecedented this soon in a mission. So everything is going absolutely perfectly. With regard to that, we have basically the perfect site, we have the perfect spacecraft, we have the perfect instruments, and we have the perfect rover, and now we're just more excited than you could possibly believe to go out there and start to investigate what's there. In addition, we have in front of us here, and you've all seen the panorama in the back, a view of Mars that we have never seen before. This site is completely different from either of the Viking landing sites. We've been to both of those. We know about the rock distributions at those sites. We know what those rocks look like, their shapes, their forms, their color, their sizes, and we didn't see anything like this at either of those two sites. So those of you that saw those Viking sites that I showed earlier, and you said, well, it looks kind of red and rocky and it all looks the same. Wrong. This place is different. And we hope to start to show you the ways in it's different. And the early indications are that we really do have a grab bag suite of rocks here. It really looks like there are different colors, textures, fabrics, sizes, shapes that are completely different from the Viking and look different from each other too. And we'll begin to show you the data here in just a few moments. In addition, the rock distributions are different. We have many smaller rocks than we ever saw at either of the Viking sites, and we have much more rounded rocks than we had. At Viking 2, the rocks were all extremely angular. We saw no roundedness, and the sizes were all very similar. We have a broad sweep of sizes, very different. In addition, at Viking 1, it took us almost the entire mission to find a dark blue or dark gray rock that was not covered with dust. And of course, as you know, this alpha proton X-ray spectrometer can only see microns thick, maybe 100 or so. And if it's covered with this fine patina of dust, we'll measure dust there. We've measured it at the 2 Viking sites. We'll measure it all over the planet. It's probably the same stuff. That's not what we want. We want to go to native rock. And the indications are excellent here that we have a wide variety of rocks that are not covered with dust, which is just exactly what we were looking for and very interested in. And finally, nothing could be going finer than the way this mission has progressed up to this date. For comparison, it took Viking 1 about a year to determine where they landed on the Martian surface. We have figured out where we've landed in 1 day. Viking 2 was never able to pinpoint where they came down on the surface of Mars because it had none of those spectacular features in the background, those mountains. And there is real science that we can do with those mountains, and that'll be shown in a little bit by Dr. Greeley. So with that, then, I'll turn it over to Peter Smith, who will show you the imaging results that we got yesterday.
Today, I'm proud to announce that we have now completed our first panorama of the landing site. And yesterday, we showed a panorama with a little bit of a gap missing. 2 frames did not come down on the first day. And the first slide, I'd like to show what was in those 2 frames. And later on, can I have the first slide, please? And later on, when you see a panoramic demonstration, these slides will still be missing because our image processing lab here has just not had a chance to include everything in the products they're generating. But this will come very shortly now. This area right here that I'm outlining with the cursor is the data that's in the gap that was missing yesterday. And you can see there's a rather interesting large rock out here. And this is really going to be a wonderful thing to study, I believe. As Matt was saying, there's a wonder to this landing site. It is diverse in exactly the way that we hoped it would be diverse. And we have found hills, we have found a nearby crater several miles in diameter, and one would expect that some of the chunks of rock that were ejected are nearby in our landing site. We see large rocks, small rocks, diverse rock types. Dr. Britt will be showing some of the differences between rocks. We have different soil types. And in the next picture, this is one of the large rocks in the scene and a very peculiar rock on the horizon that's going to be very interesting to study. This is the rock called Barnacle Bill. It's called that because in the close-up view, which you'll see in a little bit, it looks like it's covered with little lumpy barnacle-like features. Now, these certainly are not indicative of life, but they have that appearance. And some of the soils down here are disturbed by the airbags being retracted, and our rover is now right in this position at the end of its ramp. These pictures were taken before the ramps were deployed, and we do not have a current picture yet. We'll be getting that today. Next slide. This is a picture that shows a distant peak right here. If you can see this just peeking over the horizon here, it's rather faint. And this one little frame here has been shifted, and we'll be correcting that in subsequent days. But even so, you do see the distant peak on the horizon here. And of course, in this view, you see a diversity of rocks that's really wonderful to a geologist, and we will be studying these rocks. Again, they have sort of a lean to them, all of them leaning in about the same direction. And now I'll be showing, I think in the next slide, a close-up of those rocks, including this rock that looks a little bit like a table, clearly covered with dust and having some interesting linear features on it. Naturally, at some point, we hope to get the rover up for a close-up view of this rock. And again, you can see the interesting textures on these large rocks in the background. we don't have these interpreted yet. We've only just seen them in the last day. And I believe we're now ready for the view of the entire panorama. Again, the two frames that are missing, I've shown what's in them, so we really have the complete panorama. And if we can go to the video, this is the view you would get if you were sitting on Mars and slowly turning your head to look at the surrounding terrain. The objects in the foreground are obviously broken apart. This is due to parallax, and it's not obviously the fact that they are broken. It's just a parallax effect. We chose to put Mars together rather than to see Mars together instead of the close-up objects. Again, you see the site where the rover is going to be doing its first traverses. You see the rocks, huge rocks there, maybe indicative of the ancient floods. In the distance, you see two peaks. And Dr. Ron Greeley will be talking about those peaks and giving a close-up view. Then in the distance, another large rock. Now the area where the rover is, coming in on the right, Barnacle Bill, where we're hoping to go at the end of this day and take a measurement with the APXS. The strange rock on the horizon, the very large rock that's nearby that would be quite a hazard to most landing craft, but which we probably bounced over with no problem, although we're not sure just what direction we bounced in from yet. Here's the section that's missing. I showed that in the first slide. There is a large rock in that section, so we're glad to have it. In the foreground here, you see the high-gain antenna, which is sending our data back to Earth. Right now, it's pointed perpendicularly to the Earth and sending the signals back. Now there's a flat area in the background, some sort of a drift of soil. Look in the foreground here. You see that shroud? If you look very carefully in it, there's a reflection of the IMP camera sort of stretched out. Now, we have put this panorama on the web. Anybody can access it, and you will be able to use these controls in the foreground, and you will be able to look around Mars in any way that you choose. You can zoom in, you can turn your head, you can tilt. This is like a cylindrical projection, and you have the controls. We are offering this to the world on the website. Please feel free to come in and look at it and experience Mars for yourself. I think the websites have been given out before. Maybe, Matt, you know the exact address?
Yes, it's http://www.mpf.jpl.nasa.gov. We have now exceeded about 100 million hits, and we are soon to be the largest internet event in history.
Okay, I think we've shown that now. Let me say one more thing. The double peaks that we saw in the background on our first view, I was rather amazed to see that, because we had made an IMP logo a number of years ago, and if you can zoom in on this little logo on my chest, can we zoom the camera? You'll see that the M of IMP in our logo is actually a double peak mountain. Not a triple peak, not a single peak, double peak. It's fate, I believe. In fact, someone asked me yesterday how I'm feeling. But today, in driving over here, I saw a huge white statue of Jesus Christ holding his arms up in the air and looking up over the San Gabriel Mountains. This seemed totally appropriate to me. Because the joy that fills my heart has overflowed my body and risen to the heavens and has reached to Mars. And with that, I turn the microphone to Ron Greeley.
Thanks, Peter. Well, we chose this site for one reason. We really wanted to see the geological diversity that's exhibited on Mars, and we've not been disappointed. The pictures we're getting now from the IMP are showing that incredible diversity, and we've been working around the clock looking at the geology of the site. And what I'd like to do this morning is to share with you some of the results of that initial geological analysis. Now, we have on the screen the first view that Peter was referring to. This is the Twin Peaks area that we're going to refer to. And what we see here is a lot of detail that was really had no idea existed when we were looking at this area from orbit. And what I'd like to do is to draw your attention first to the peak on the right. And you'll notice this white stripe here. This has informally been referred to as the ski run. And at this point, we're not really quite sure what that is, but it's probably material, drift material that's moving down slope under the influence of gravity and leaving that bright stripe behind. Now, in later views, we hope to be able to look at this under different illumination. And we want to see if there's any topography along that white stripe. It could, in fact, be a gully-like feature. And if that's the case, then this is going to give us new insight into processes that are modifying the surface of Mars. Now, this particular conical structure has a smooth apron that's surrounding it. And this is very reminiscent of what we see in our home in southern Arizona, where the hills, the material is just sloughing off the sides and building up an apron like an alluvial fan. Now, we don't know if this is the result of water emplacement, runoff, or if it's simply downslope movement under the influence of gravity. Now, let's turn our attention to the hill on the right. This is on the north side, and what we find really fascinating here is a series of horizontal bands. And in fact, we've counted 4 or 5 individual levels of these horizontal bands. Now, these could be either sedimentary layers, like we see in the walls of the Grand Canyon. They could be deposits that were banked up against the hill from water, or they could be terraces cut by erosion. These are all ideas that we're exploring currently. But the point is, these all are indicative of water activity. And as you know from previous briefings, this is in the floodplain of the Ares Vallis. The point is, we see evidence of multiple episodes of flooding, not just one catastrophic event, but many events. And the banding that we see here is an indication of that multiple event, okay, multiple flooding. Now, let's go to the color Twin Peaks view. We back off a little bit now, and here are these peaks. These peaks are a little over a mile away from the lander and stand several hundred meters high. Now, in the foreground, we see a variety of rocks, and some of these have already been talked about, but what really fascinates us are these rocks that are so rounded. And this, of course, is consistent with transport by water. And in the coming days and weeks, we're going to be able to look at the sizes of these rounded rocks and estimate the amount of water that carried them and emplaced them into their present location. These are some of the quantitative studies we'll be able to do with these pictures. We did not see rounded rocks like this at either Viking landing site. We also see a lot of rocks that are tabular and angular. And these angular rocks have been shaped by a different process than water. And there is a crater that's about 1 kilometer away from the landing site. It's not a big crater. It itself is only about 1 kilometer across. But that's large enough to penetrate down through the sediments, excavate rocks, bring them up to the surface, and throw them into the landing site. And so we have rocks that have been clearly transported here by water from upstream, probably from a long distance, and we have rocks that have been derived locally. And the diversity of those rocks is not only indicated by their shapes, that tells us something about their geological history, but now we can also look at their compositional and spectral characteristics. And with that, I'll turn it over to Dan Britt, who will talk about the spectral characteristics.
Okay, thank you, Ron. Can I have the first slide, please? Or the next slide. Okay. What I have to show you today are two spaces. There we go. Are two studies of rocks and soil in 3 colors. This is basically the results of our mission success pan, looking at them in red, green, blue. And even with those few colors, remember the IMP has 12 colors in total in the geology filters, we can tell that there's a great deal of variety. And I think that's the message that we're bringing here, is that we've got a cornucopia of rocks, soils, and processes. So this is a great example of what went on in Mars, maybe in the early days, maybe in its middle age. So the first slide I'll show after this is of this area, and then we'll go over to this frame, which shows half of Barnacle Bill. So the next slide, please. Okay, this is a color image, 3 colors, red, green, blue, and a series of rocks. 1 and 2 are 2 rocks. Now notice something about these 2 rocks. You don't see a lot of detail, but one thing you don't see is they're not very red. The red.
You've been watching a live news briefing from the Jet Propulsion Laboratory in Pasadena, California, where there appears to be utter elation by NASA officials there. The Sojourner wheels are in motion on the Martian surface, and according to Dr. Matthew Gollenbeck, the GPL project scientist, the Sojourner is fully functional, and everything is going, as he said, absolutely perfectly. He said that the Sojourner has taken a panorama picture, which is more or less a planning tool, which will tell them where exactly Sojourner is and where they'd like to take it next. It also showed them a special rock, Barnacle Bill, which may be the first target for Sojourner, a rock that appears to have barnacle-like matter on it. And we'll learn more about that later, seeing as Jim Hill is at the news briefing, and we'll hear from him later. That wraps up this news briefing, live news briefing from On the Mission to Mars. CNN World Report is coming up after this break with the latest on the election in Mexico.
Ein kleiner Roboter ist in die Raumfahrtgeschichte gerollt. Nur 10 Zentimeter hat das Marsmobil auf der eisigen Fläche des roten Planeten bislang hinter sich gebracht. Und dort soll es erstmal bleiben, um den Sandboden zu erkunden. Gesteuert wird das 1 Meter große Fahrzeug von der Erde aus. Hier im kalifornischen Kontrollzentrum in Pasadena sitzt der sogenannte Fahrer des Mini-Vehikels. Anhand der Bilder vom Mars wird über den Kurs des Mobils entschieden. Bislang klappt alles wie am Schnürchen. Was für ein Tag das gestern war, aber jetzt funktioniert ja alles, die Sonde und vor allem unser Roboterfahrzeug. Diese Computeranimation zeigt das wichtigste Instrument, das in Deutschland größtenteils entwickelte Spektrometer des Roboters. Es presst sich an Sand und Steine und analysiert sie chemisch. Während das Mobil rollt, wird auf der Pathfinder-Sonde die Kamera voll ausgefahren, um weitere Panoramabilder der Umgebung zu liefern. Mit den ersten spektakulären Farbaufnahmen fesselte die amerikanische Raumfahrtbehörde NASA die Öffentlichkeit. Die NASA kann jeden Erfolg auf dem Mars gebrauchen, denn es gilt, einen skeptischen US-Kongress zu überzeugen, mehr Mittel in die Raumfahrt zu stecken. Das wird schwierig seit dem Problem mit der russischen Raumstation Mir, unter denen der amerikanische Astronaut Foley zu leiden hat, fragen amerikanische Politiker immer öfter, wie viel Sinn Projekte im All überhaupt noch machen.
Das Marsmobil, der kleine Sojourner, der wie ein Spielzeugauto aussieht, hat heute seinen ersten Ausflug auf dem roten Planeten gemacht. Eine Schnüffelfahrt. Die NASA jubelt, es läuft wie am Schnürchen. Und das will schon was heißen, wenn man ein kleines Auto über 500 Millionen Kilometer hinweg fernsteuert. Alexandra Späth berichtet.
Für die Wissenschaftler der Raumfahrtbehörde NASA ist die Welt wieder in Ordnung. Mit einem Tag Verspätung konnten sie einen Rundumblick aus der US-Sonde Pfadfinder präsentieren. Und das Roboterfahrzeug Sojourner kann auf seine erste Erkundungsfahrt gehen. Mein Herz ist voll Freude und ich bin so glücklich, das alles erleben zu dürfen, strahlt Peter Smith, führendes Mitglied im Forscherteam, mit seinen Kollegen um die Wette. Denn gestern Abend noch lag das Gelingen der Mission in den Sternen. Beim Versuch, Sojourner auszufahren, versperrte ein Airbag den Weg. Sonde und Fahrzeug reagierten nicht auf die Befehle von der Erde. Nach stundenlanger Hochspannung dann die große Erleichterung. Der Roboter verlässt die Sonde und rollt über eine Rampe auf dem Mars. Sojourner soll mit Röntgenaugen, das heißt mit einem Alpha-Proton-Röntgenspektrometer, das Gestein und Boden analysieren. Von einer deutschen Firma entwickelt, kann es rund 90 Gesteinsformationen chemisch analysieren.
A tiny space explorer gets ready to roll. Rover makes tracks on Mars. Hello from Atlanta, I'm Lyndon Souls. Welcome to Early Prime. Gene Meserve has the day off. The movements of a motorized rover about the size of a microwave oven 120 million miles away from us continues to mesmerize us. In about 9 hours, a Russian cargo ship is scheduled to dock with the Mir space station, bringing materials the Mir crew will need to repair its damaged space station. But on Mars, the little rover named Sojourner heads out to its first destination today, a rock named Barnacle Bill. CNN's John Zarella joins us from Pasadena, California, with the latest news from space. John?
Lyndon, it appears that Sojourner is exactly that. It's the little rover that could, and it's going to start sending back and may already be sending back some very historic data. It was only about 12 hours ago when it rolled off of the lander, down the ramp, and made history, being the first autonomous vehicle to roll across another planet. And for the geologists, that was a great, great moment. They are seeing at this site what they call a grab bag field. It is filled with all kinds of rocks and features that they want to get to know better. And by using Sojourner, they'll have an opportunity to know it better. Already they're speculating about some things that they didn't think. They believe now that many eons ago, it may have been not one, but more than one torrential flood that blew down into this floodplain and created this tremendous area of rocks that they can now explore. And some excited scientists talked this morning at a briefing that CNN's Jim Hill attended.
Photos from Pathfinder clearly show the historic moment as Sojourner, the little rover, crept onto the Martian soil, much like the epic day when humans stepped onto the moon decades ago.
She is the robotic equivalent of Neil Armstrong for Mars.
The rover has already sniffed the ground with its alpha proton X-ray spectrometer, and the Pathfinder team has identified the next target, a nearby rock nicknamed Barnacle Bill.
It's called that because in the close-up view, it looks like it's covered with little lumpy barnacle-like features. Now, these certainly are not indicative of life, but they have that appearance.
The Pathfinder's two eye-like cameras have sent back a panoramic view, 360 degrees around the landing site. Scientists have identified a wide variety of rocks, some jagged, perhaps tossed by a violent event. Others are rounded, indicating they may have been pummeled by huge floods over long distances.
We have basically the perfect site, we have the perfect spacecraft, we have the perfect instruments, and we have the perfect rover. And now we're just more excited than you could possibly believe to go out there and start to investigate what's there.
The Pathfinder team has dubbed nearby mountains the Twin Peaks, with a white area they call the Ski Run, although its composition is a mystery. Scientists are so anxious to examine the diverse landscape they see on the red planet that they're doubling the rate at which they can retrieve the information. But being able to reach some 119 million miles into space is being felt emotionally as well.
The joy that fills my heart has overflowed my body and risen to the heavens and has reached to Mars.
Jim Hill, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
During the nighttime on Mars, of course, Sojourner's spectrometer its nose was down in the soil, taking soil measurements, examining the soil, and we hope that in the next 3 to 4 hours, the scientists here will be able to tell us something about the geology of Mars, something that they have been waiting many, many years since the Viking missions 21 years ago to find out. There are, of course, more briefings scheduled this afternoon and evening, and we expect to have some more fabulous pictures downlinked from the Martian lander sometime later this evening. This is John Zarella reporting live from the Jet Propulsion Laboratory in Pasadena. Back to you, Lyndon.
All right, thanks, John. We'll be staying tuned.
The Global Surveyor spacecraft left Earth a month before Mars Pathfinder.
We have ignition, and we have liftoff of NASA's Mars Global Surveyor as America begins its journey back to the Red Planet.
But because of a longer flight path, won't get to Mars until September. And it won't land either. Global Surveyor will go into orbit around the planet and spend the next 2 years mapping the entire surface.
I can't help but believe that there is something very exciting to be found out of this mission. I don't know enough to put my finger on what it is, but it's there. It's there.
Since the announcement last summer that Mars meteorites might contain primitive Martian life, there's been a renewed interest in answering that ages-old question, once and for all. Surveyor can't do that, but its detailed maps should help scientists decide where to go to look for life.
We're going to really look at the whole surface of Mars and put a database together that's going to make it possible for these missions that are going to be going off in the future to optimize their probability of learning something about whether there is life.
During the next decade, no fewer than 10 orbiters and landers, a virtual armada, will invade Mars. What they find may profoundly change how humans treat planet Earth.
A lot of times people say, well, we're going to Mars just to understand Mars. Well, we're going to Mars to understand the Earth.
Scientists want to know why life developed only on Earth. What went wrong on Mars? It's cold and dry. What went wrong on Venus? It's hot and moist. Is the evolution of the Earth headed in the direction of one of those planets? If so, can it be stopped? Global Surveyor will, project managers say, go a long way in answering those questions. During its 2-year mission, Surveyor will return more data than all the past planetary missions to Mars combined. John Zarella, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
Pictures from another world, the latest dispatch from Mars. New pictures from Mars offer clear evidence of water there a long time ago. This shows the path the Sojourner rover made as it rolled away from the Pathfinder spacecraft. The Sojourner is a small robot, and its mission is to study the chemical makeup of Mars's rocks and soil. Scientists released a photo showing Pathfinder from Sojourner, and they showed Sojourner pressing its sensor against a bumpy rock known as Barnacle Bill. Mission scientists also released the first high-resolution color picture from Mars, and geologist Ronald Greeley outlined evidence there had once been water there. He said rocks lined up in a row show clear signs they'd been swept along in an ancient torrent of water.
Well, we're now into the second full day of the travels of Sojourner. The little Mars rover has now moved about 40 centimeters and run into a Martian rock nicknamed Barnacle Bill. Well, joining us with the latest is CNN's John Zarella at the Jet Propulsion Laboratory in California. John?
Hillary, it's amazing how much fun the scientists and the mission team here, the engineers, are all having on this mission. It could not have gone smoother since Friday, from the landing, from the rover getting off of the vehicle, and from all the wonderful science that they are beginning to gather. It's beyond any of their expectations they have been telling us all day. Today they had a science briefing, some fascinating new information coming out already about the nature of the flood, or perhaps floods, that went through this particular area where they have landed. New indications of water, obviously, on Mars at some time ago in the past, which is, of course, an indication of perhaps life some time ago. You got to have water to have life, and there certainly appears to have been plenty of water on Mars at one point in time. Joining us to discuss some of the fascinating things that they are coming up with is Donna Shirley, the head of Mars exploration here at JPL. And hard to keep your feet on the ground these days, isn't it?
Yes, it certainly is. It's been really exciting. It's just everything is just going swimmingly. In fact, we suspect that even the communication glitch was caused just to add drama to the whole thing. It was going too well.
There were a few bits of drama that you added. Now, one of the pictures that was released today showed the rover up against Barnacle Bill.
Barnacle Bill, yes, and there in the picture, I think they're showing Barnacle Bill, and the rover has backed up to the rock and put the alpha proton X-ray spectrometer up against Barnacle Bill to measure its elemental composition, that is, its chemistry.
And how long? It stayed there pretty much all night, right?
Yeah, it stayed all night, and it takes 10 hours to get a good spectrum out of this little instrument. And tonight they'll take off and head for another area.
And when you were up against that, it was a first time, and you hit it right away. I hear they never did that in practice.
Well, it turns out in practice they were using the old beat-up spare rover, whose name is Marie Curie. And poor Marie has been used so much that she's not quite as accurate. And here we have a nice brand new shiny Sojourner that just stuck it. Absolutely stuck the landing.
And there was an absolutely fabulous picture taken, finally got it back,
right,
of the lander from the rover.
Yes, and the rover looked, and sure enough, those pesky airbags that were bothering her from getting off, there they are, sticking up and making a big mess. Now, this is the first time that two spacecraft have ever taken a picture of each other, two robotic spacecraft. So this is really a first. And in the upper right-hand corner of that picture, you can see the high-gain antenna on the lander sticking out. The rover will take some more pictures of the lander later.
Now, we want to take a look at a panoramic image that was put together a couple of days ago.
Right.
That's the first one.
Right.
And now give us an idea of how that looked.
Okay, well, here's the panorama, and it looked wonderful. It was the first time we'd ever seen an interesting area like this on Mars. And it's got hills in the background. It's got a whole variety of rocks. But the point of view of this image was with, you know, like your neck, as if your head were around your knees. And so then today they got back what's called the monster pan, and that means a panorama where they take it with all the different filters on the camera, and there are 12 different filters, and they take it in much better resolution, so it takes a long time to get it down. But pieces of it are indeed coming down and were shown at the press conference this morning.
And it gives you, because it's from a higher angle, as if our height,
right,
you get a different perspective on the size of the rocks.
Right, absolutely. And in fact, Peter Smith, the principal investigator on the camera this morning, said that, you know, a lot of rocks they thought were really big turn out to only be a foot or two high, so it's not as frightening as it appeared. But they were able, for instance, the couch rock in the background, they thought looked a lot closer than it really is. And when they stood up, they were able to see that it's indeed quite a ways away and on the horizon.
Now, quickly, the rock that they're going to go to now is nicknamed
Yogi. And somebody thinks it looks like Yogi Bear. Don't ask me why. And what the rover is going to do tomorrow is take off leave Barnacle Bill. She has now tasted Barnacle Bill. She's now going to go over to a soil area right in front of Yogi and do some soil mechanics experiments. And that means she's going to spin her wheels and make holes and take pictures of the holes and generally mess around in the dirt. It would be fun, like playing in a sandbox. And then the day after that, and then that night she'll put the spectrometer on the ground again, and then the next day they'll try for Yogi to get the spectrum.
Donna Shirley, again, thank you so very much for taking time to join with us. It's certainly easy for them to be so upbeat as well as everything has been progressing here, and continuation of just some fabulous science and tremendous images from Mars are going to continue to pour in. Hillary?
Thanks, John. We'll count on you to keep bringing us good news. John Zarella there. Well, there is much more information on Pathfinder available online at CNN Interactive, including images and links to the NASA site. The address on the web is cnn.com/Mars.
War bereits fleißig. Dank seines Spektrometers untersuchte er den Sandboden unter sich und fuhr dann an den ersten Brocken heran. Bereits heute bekommt Sojourner die neue Order von der Erde, das nächste Ziel anzupeilen, einen größeren Marsstein vom Kontrollzentrum Yogi getauft. Die Ergebnisse der Bodenproben liegen morgen vor. Am Ende des zweiten Marstages haben wir die Kamera voll ausgefahren und jetzt sehen wir den Landeplatz im Stehen und nicht mehr im Sitzen. Und viel präziser. Diese gestochen scharfen Bilder vom Landeplatz sind die neuesten, die NASA zu bieten hat. Sie zeigen rings um die Pathfinder-Sonde die uralte Ebene Ares Vallis, ein Traum für Geologen. Wissenschaftler finden hier klare Zeichen dafür, dass auf dem roten Planeten gewaltige Fluten rauschten. Die Anordnung der Rillen und der Kämme in den Felsen zeigen, wie dicht und gewaltig das Wasser über sie hinwegfloss. Die Wassermassen müssen die Steine von westlicher in südliche Richtung gedrückt haben. Wir kommen dank unserer Farbbilder zum Ergebnis, dass die Oberfläche des Mars sozusagen rostet. Das erklärt den roten Staub. Die Ergebnisse der Mars-Mission lassen sich im Computernetzwerk Internet mitverfolgen. Auch dafür hat die NASA gesorgt. Sie richtete entsprechende Webseiten ein und erntet weltweites Interesse. Über 100 Millionen Menschen wählten sich in die NASA-Webseiten ein. Das hat es in der Geschichte des Internet noch nie gegeben. Die Premieren reißen nicht ab, auf dem roten wie auf dem blauen Planeten.
Und zugeschaltet aus Hannover haben wir jetzt den Mann, der am Max-Planck-Institut für Aeronomie für den deutschen Projektanteil bei dieser Mars-Mission zuständig ist, Professor Detlef Koschen. Ich grüße Sie, guten Abend.
Ja, schönen guten Abend.
Ja, uns Normalbürger faszinieren ja ganz andere Sachen als Sie. Aber war es für Sie auch erst mal ein bisschen bewegend, das Ganze?
Ja, auf jeden Fall, natürlich. Wir haben uns die Nacht von Freitag auf Samstag um die Ohren geschlagen und auf die ersten Bilder gewartet. Und das war natürlich sehr spannend für uns.
Sie haben ja nun im Institut das Herzstück der Mars-Kamera entwickelt. Was ist denn daran so besonders? Ferngesteuerte Kameras gibt es viele, aber was muss diese Technik Besonderes leisten?
Ja, das sind ein paar verschiedene Sachen. Das eine ist natürlich, dass wir dort oben nur eine digitale Kamera verwenden können. Die gibt es zwar jetzt seit ein paar Monaten auch zu kaufen, aber so gut wie unsere sind die nicht. Und wir waren schon vor ein paar Jahren mit der Entwicklung dieser Kamera fertig. Das Zweite ist, dass wir ganz genau wissen, wie diese Kamera funktioniert und ziemlich genau sagen können, was wir sehen. Viel genauer als mit einer normalen Videokamera oder sowas. Und nur so kann der Wissenschaftler dann auch wirklich mit den Daten was anfangen.
Das Spektrometer, von dem ja schon so viel die Rede war, das ist ja auch am Max-Planck-Institut entwickelt worden, allerdings in Mainz. Was erhofft man sich denn von den Sandanalysen? Wo Wasser war, könnte sogar noch Leben sein?
Ja, das werden wir sehen. Also dieses Spektrometer, das ist ja so eine Art Nase, die der Rover benutzt, um die Gesteinszusammensetzung herauszufinden. Und da wird man sicher Informationen darüber kriegen, ob es nun möglich war, wo wir noch Wasser haben auf dem Mars oder ob es früher mal Wasser auf dem Mars gegeben hat.
Professor Koschen, was glauben Sie, was bedeutet dieser Erfolg für die deutsche Forschung insgesamt?
Ja, wir erhoffen uns natürlich einen Aufschwung in der deutschen Forschung. Es war ja viele Jahre gerade um den Mars ruhig. Wir haben jetzt gezeigt, dass wir mitmachen können, dass wir also durchaus vergleichbare Sachen bringen können wie die Amerikaner. Wir haben mehrere Institute in Deutschland, die damit beteiligt sind, mit sehr, sehr wichtigen Anteilen. Und es geht schon weiter. Wir sind also schon bei der nächsten amerikanischen Mars-Mission mit einer komplett eigenen Kamera diesmal dabei. Und wir erhoffen uns natürlich weitere zukünftige Zusammenarbeiten.
Und schauen wir mal, was bei den nächsten Missionen so alles herausspringt für die Deutschen dabei. Ich danke Ihnen erstmal. Vielen Dank nach Hannover.
On Mars, a tiny roving device is continuing its data-gathering adventure on the red planet. CNN's John Zarella is in Pasadena, California, where scientists are planning Pathfinder's moves. John, any discoveries today?
Well, I can tell you, Judy, that Pathfinder is just generating a tremendous amount of interest. 100 million hits on JPL's website. And here, as we showed you last week, a Hot Wheels toy that's been made, the JPL Sojourner Mars Rover. Reason I'm showing you that is because now take a look at this line over here. These are employees from the Jet Propulsion Laboratory standing in line to get one per person of these Sojourner rovers. And the line stretches, snakes all the way around this area here and around a fountain, and it's just incredible. And I know one person who never would have expected this is our guest, and that's Bob Anderson. And Bob, you are a geologist here with the Jet Propulsion Laboratory working on this project. And some of what we've seen, obviously inspiring everyone. A picture today of Barnacle Bill and the Sojourner rover. Tell us about what you are learning from the images that you are seeing.
Okay, well, what you've seen in some of those images is that the landing site we picked, the Ares Valley's landing site, is a very diverse landing site. There are more rocks out there than all of us can even imagine that we can see.
There's Barnacle Bill to the left, and I think that's Yogi in the distance.
That's Yogi in the distance. What we did is we commanded the rover last night, Sojourner, to go over to Barnacle Bill and put its alpha proton X-ray spectrometer on the rock. That data is not down yet. It'll be down later on this afternoon, and this is actually this will be the first rock on the surface of Mars that we actually get the chemical information from in history of man.
Now, what are you going to do with the Sojourner next? Where does it go next?
Our next mission with Sojourner is to turn around, and there's an area right to the closest to us, Yogi. It's a very flat area. What we're going to do is we're going to instruct Sojourner to go over there, and we're going to turn around and have what's called a wheel experiment. And what it's going to do is it's going to lock its wheel in space, and then turn around and spin one of its wheels.
There's a panoramic image, I believe, that really shows quite clearly exactly where you're going to go.
That's right. If you go over to, if you look from that image and go straight and over to the right, you'll see that what happens is that flat area right there in the center is where we're going to send Sojourner first.
Before it goes on over to Yogi.
That's right. And what that will do is that we'll spin it in, and it'll give us an idea of what the soil is like, how cemented it is. We think it's very, very hard, and so as it goes over, the wheels, we measure the wheels, and it'll just cut through the ground like a plow does. And then what happens, we'll turn around and redirect it to the left of Yogi, and for tonight, when it puts its alpha proton X-ray spectrometer down, it will put it on the soil that's right next to Yogi and give us a composition of the soil next to Yogi. And then hopefully by tomorrow, we'll put it on Yogi itself.
A last quick question. Did you ever expect to get the amount of information you're getting and the quantitative pictures you're getting so quickly?
Oh, no, we didn't. In fact, our early data down rates were only about 2 megabytes, 2 kilobytes for the entire downlink, and we're up to like 8 kilobytes. So what happens, falling off this thing. What happens is that we're going to turn around, and with the data rates increasing, we're getting more and more images back. And so eventually, by the end of the day, we hope to have just a tremendous panorama of the entire area.
Bob, thank you very, very much for taking some time to join. This has really become a very, very busy time for the scientists here. The mission is on track. Everything is working well. So now the mission team can take a break, and it's time for the scientists to really get back to work and get down to business. Judy?
All right, John Zarella, thanks. And just to clarify, Pathfinder is the spacecraft, and the rover has been named Sojourner. Thank you, John.
History will remember a little rover that could, and rocks with cartoon character names.
That our rover has nestled up and kissed affectionately Barnacle Bill. We've decided that we're going to keep all the names light and airy and sort of in a sort of a nice way. Something about the rock that sort of reminds you of it. No naming people, no formal names.
Monday, there were new pictures. Sojourner snuggling up close to Barnacle Bill, and a picture of the lander taken from the rover.
This is the first time that two spacecraft have ever taken a picture of each other, two robotic spacecraft. So this is really a first.
Sojourner is taking center stage. A panoramic image shows where the rover will drive off to next. First, a stop to play in the sand. By stirring up the soil with its wheels, geologists will get a look at the dirt below the surface. The rover's next rock target is named Yogi.
We'll turn the rover and drive towards Yogi, and at the end of the day, we'll take a full stereo from the rover eye, nice up and close. That's the way geologists want to look at it, nice up and close, and see what we can see in that morphology.
The scientists are having a field day with more images and data than they ever expected, and a landing site described as the perfect grab bag. The angles the rocks are facing is providing mounting evidence of the direction in which one or perhaps several catastrophic floods swept through this region eons ago. So far, the easiest job has been left to the meteorologists, at least as far as predicting Mars weather.
All this forecast is based on a sophisticated technique widely used on the Earth, which is to say that the weather today is exactly the same as the weather yesterday.
The high Monday on Mars, 10 degrees Fahrenheit. The low, minus 105. Science has now taken center stage. Some 70 investigators are poring over the pictures and data. And the mission is generating more worldwide interest than anyone imagined. Just the website here has received 100 million hits.
Here you go. Thank you. This is really cute. I love this.
At souvenir stands at the Jet Propulsion Laboratory, a line of people snaked a couple hundred yards, all waiting to buy a toy replica of the spacecraft and lander. 1,500 sold out in 30 minutes. John Zarella, CNN, Pasadena, California.
We continue to have a spacecraft in excellent health. We have a rover in excellent health, and we have all instruments in excellent health. We had 2 downlink sessions yesterday, one in the afternoon at about 4, for about a half an hour. That was the start of the day on Mars. And one at about 11:30 p.m., which was sort of the late afternoon on Mars. From those two downlink sessions, the transponder working at 8,500 bits per second, we returned over 50 megabits of data from the surface of Mars again. To this date, we have returned 1,575 images from the surface of Mars. We returned the entire monster pan, which in our previous expectations took us a week to get down. And we have actually started receiving the insurance pan, the lossless panorama from the pre-deployed state as well. We retracted the APXS from Barnacle Bill. We moved away from the rock. We backed up. We did a series of soil mechanics measurements yesterday where we rotated the rover wheel and actually dug the wheel in and plowed forward. We did a wheel abrasion experiment, and we moved toward Yogi and did a series of high-resolution forward stereo views of this very interesting rock. Today, we plan to do a whole variety of imaging experiments, including a series of multispectral spots. We plan to move, we will be imaging Barnacle Bill in much more detail than we have so far. We will look at a series of broken crusts that we saw yesterday. We will also look at Scooby-Doo in some detail. And Casper, don't forget Casper. We expect the rover to move to crab to the left and move to the southeast side of Yogi. To get a better look, we will take a forward stereo shot of Yogi in hopefully better light, and then we will turn the rover around to where the rear is pointing at Yogi, and we will take a rear color image of Yogi. And then we will place the APXS down against the soil in preparation for trying to get the APX up against Yogi the next day. We will continue to get meteorology data from the surface of Mars, and we will start a rather aggressive series of dust opacity measurements and nighttime observations of the sky of Mars in preparation for synergistic measurements with the Hubble Space Telescope, which start tonight and then go for the next 3 days. Phil James and his team at the University of Toledo will be imaging our hemisphere of Mars using Hubble to see if we still have this ambiguity of bright white clouds versus what we see down on the surface, which is what we saw throughout the Viking experience. And we should be getting down the insurance pan as well. We have decided to delete the morning transmit session for today in preparation of trying to recharge the battery. The battery on the lander is a rechargeable battery. If you don't recharge it every so many days, it degrades in performance, and we wish it to remain healthy for as long as we can. We've decided to delete the morning half-hour transmit session, which takes a heavy toll on the energy usage of the battery. The good news is our remarkable engineers have figured out a way to get 2 downlink sessions in the afternoon of roughly total 3 hours duration, and so we expect to be returning an unprecedented 85 megabits of data from the surface of Mars tomorrow. So even though we are not doing one session, we get a net gain. Here today to talk about the science that we're beginning to see. The more we look at this site, the more we are immensely happy at the variety of materials that are there. We see a whole wide variety of surface finds. We do see what looks like to be a wide variety of rock types as well, and I could have only hoped this in my wildest dreams. Here to talk about the data we've gotten yesterday is Rudy Reeder, who will show the alpha proton X-ray spectrometer of Barnacle Bill. I should note that at this point that this is an historic moment. We have never before gotten a chemical analysis measurement of a rock on Mars. Following that will be Hap McSween, who will discuss how Barnacle Bill relates to the suite of rocks that we think we already have from Mars, the remarkable SNCC meteorites, and how they relate to rocks here we have on Earth, and what kind of rock this might actually be. Following that, Peter Smith will talk about the results of the monster pan. We have all of that down, and we've begun to start to put it together and look at the colors and the stereo as well. And that's a remarkable, remarkable data set. Followed by Nick Thomas, who will show you imaging of Deimos, the first ever image of Deimos from the surface of Mars, images of the sun, images of the sunrise as well. And finally, for the weather report on Mars, Jeff Barnes. I'll turn it over to Rudy.
Thank you, Matt. Good morning. Can I have the first picture, please? Okay, this is the APX spectrometer mounted on Sojourner on Earth, and the next one should show you how it looked on Mars when it was taking data from Barnacle Bill. Next one, please. The upper image shows you the rock that we have taken data on, and the lower image shows you the position of Sojourner. Unfortunately, you don't clearly see the APX docked against the rock. There's a left eye picture where it is better visible. That much about the scenery. Now, as far as the data are concerned, the whole project went so smooth so far that many people might have been taken to believe that this is a hoax. There was a film made many years ago, I think it was called Capricorn, where NASA was putting up state. Well, we can assure you it's not a hoax. If I can get the next image. Here is a diagram of elemental ratios and the many data points plotted in there. They represent basically samples from Earth, and if I could learn how to operate this, I again can't. Can you? Oh, here it is. So this is terrestrial samples lined up here. This collection of triangles is data from meteorites believed to come from Mars. Down here you have one data point, which is Viking soil, the soil measured by Viking. And the red dot is Barnacle Bill. We are on Mars. We get excellent data. We have especially good X-ray data. And that makes my colleague, Tom Economou from the University of Chicago, very happy. It was mainly his task to build that X-ray channel. The next slide will show you an example of Barnacle Bill's X-ray spectra and how Tom has been preliminarily decomposing it. We have actually not had such good data in the laboratory. That's mainly due to the fact that on Mars it's much colder than we ever bothered to cool the instrument when we took spectra in the lab. We have slight problems understanding the alpha data. The data are also excellent, but they include a contribution from the Martian atmosphere that we have to take out, and there we are still chewing around. Please remember, analyzing these data is not as simple as just taking temperature, pressure readings and plotting them. There's a lot of work involved in retrieving the information. The next slide will show you what my boss Heinrich Wenke in Mainz and chief geologist Emil Jaguts think that Barnacle Bill is like. Forget the upper row because that's just analytical data. Forget even the block of data where they have broken it down into mineral phases. Mainly they say this rock consists of about 60% a rocky phase and 40% of a mafic phase because the color is black. Emil thinks it could be an impact melt. Hap will tell you a lot more about the interpretation of these data, but this is just front-end, first preliminary opinion of our people back home. Now, that's about all I wanted to tell you about our data, our instrument. I just wanted to make another small note. This X-ray spectrometer that gives us such beautiful data is another example of the very successful application of the cheaper, faster, better approach. The actual detector is a Japanese photodiode that costs $6 a piece. And the whole detector package that includes this detector plus a preamplifier, all mounted on a thermoelectric cooler, then a collimator, a thin beryllium window, and all of this in a hermetic metallic can runs for about 20,000 bucks. Thank you.
And listening there to the scientists at the Jet Propulsion Laboratory in Pasadena telling us the first data they've had on the actual chemical composition of the rocks as the little Sojourner goes out and takes a chemical decision and investigation in terms of what those rocks on Mars are about. We'll be talking all about this and what it maybe tells us about Mars, what it's made of, and whether there was ever any possibility of life there in just a moment when we come back and we talk to our guest here from the Smithsonian, Curator of Meteorites, Mr. Glenn McPherson. Stay with us. Is there or was there ever life on Mars? That's a question mankind's been asking more or less since the ancient Romans named the red planet after their god of war. And joining us to help consider the clues that someday may answer this age-old question is Glenn McPherson, Chairman of the Mineral Sciences Division at the Smithsonian Institution and also the Curator of the National Meteorite Collection. Well, Mr. McPherson, thanks so much for being with us. From what we heard there, the preliminary chemical analysis, what have you learned?
Well, first thing I learned is that, in fact, it adds greater confidence in my mind that the meteorite samples that we think came from Mars really look like Mars. The rock that they've analyzed so far, and I haven't seen the complete analysis, looks very similar in its chemical properties to some of the meteorites that we have in our collection. This adds additional weight to the idea that these samples that we have at the museum here in Washington and elsewhere really are from Mars, and that in using them as a guide for future exploration of Mars, we're on the right path.
And this is, let's be clear, the famous meteorite that gave scientists the suspicion that there were possibly signs of evidence of life in Mars.
Well, that's one of them. There are 12, actually, and they are quite different in their properties. Most of them are igneous rocks, which means that they formed from molten rock long ago. That happens to be a very special one, partly because it comes from the highlands of Mars, partly because it's much older than all of the other Martian rocks that we've seen so far, and of course because it has these little patches of the mineral calcium carbonate in which the scientists at Johnson Space Center and elsewhere suspect they found evidence for life.
So do you think with the further investigations they're going to make of the other rocks that you might confidently in your own mind at the end of this mission say, hey, I think we really do have Martian meteorites here?
I think that this adds great weight to it. I don't think that we're going to know the answer to that for certain until we go to Mars and bring samples back, which we're all looking forward to. But I think that the analyses that we'll get, the Martian meteorites that we have, are sufficiently different from their Earth counterparts, Earth igneous rocks, that we should be able to tell that, in fact, the rocks that we're looking at in the meteorites are Martian by comparing them with the Martian analyses.
What about what they're all telling us, that it's red because it's really rust, it's iron oxide, and we're seeing so many of the same elements that we see here on Earth, the same chemicals? What does that tell you?
Well, chemistry is the same no matter where you go. The rust, the question there is being able to see beneath the rust, beneath this dust that permeates Mars' surface, looking below that rust to find out the composition of the rocks underneath. But many of the rocks are similar to ones that we see here on Earth in their origin. They're volcanic rocks. There are giant volcanoes in Mars, just as there are here. But as I say, the chemistry of those rocks that we've seen so far are different in subtle ways.
The laws of physics are also the same. They're talking a lot about how they have clear evidence this was a huge flood, and then a huge floodplain is left over. That does suggest possibility of life, doesn't it?
Well, the flood suggests the possibility of water. And if there was a lot of water on the surface of Mars, and if indeed the temperatures were warmer long ago, those are certainly two things one would want to see if one thinks that life was once there.
And that's all you read into it. Even if it was 1 billion or 3 billion years ago, that's it. Not water is a key ingredient to life.
Well, of course water is a key ingredient to life, and this, what they're seeing on the surface, is evidence for water in its most violent form, if you will, catastrophic floods of an unimaginable scale here on Earth, perhaps. But they're also seeing evidence that when these floods receded, that there were puddles of water left behind, and of course what they really would like to find evidence for is water that was still, that was in one place for a long period of time, so that things could start to grow.
Has this Pathfinder mission already exceeded your expectations?
I would say yes. I would say that it has certainly performed flawlessly. I think everybody is elated about that, and what most of us are very excited about is that it is laying a very solid foundation for future Mars missions, including, we hope, the one that will bring samples back from the surface. And as a first critical stepping stone, it has been just perfect.
Thanks for being with us and for your analysis, Mr. Glenn McPherson from the Smithsonian Institution here in Washington. Thank you.
Thank you.
After setting records in space, the tiny Mars rover will likely set records in cyberspace with tens of millions of internet viewers.
It was totally awesome.
It's very exciting. It's very clear. You know, this is live. This is real Mars.
Internet services from AT&T to Netcom to Yahoo reported up to double the usual traffic. Webmasters at Jet Propulsion Laboratory pumped out the famous Mars panorama shot.
That will allow you to basically point yourself around the horizon and look all the way around in beautiful color, the exact same color that you'd see on Mars, and it's the closest you can get to being there.
The NASA data was relayed through dozens of helper computers, so-called mirror sites across the globe.
We've had hits from everywhere. The first people that I saw at the site were from Korea and from South Africa. Just the impact is just so tremendous, and seeing all these people get together to see this, it's really cool to watch.
News sites like CNN Interactive and CNN Custom News reported more than 10 million page requests.
We've gotten a lot of feedback, especially from younger folks who say that this is their first really big space mission or event.
Other news services also reported high traffic. Teachers visiting San Francisco's Exploratorium use the Mars internet data as instant teaching aids with information so new it's not available in any textbook.
Be able to go to all of these astronomy sites all around the world within, in seconds is phenomenal.
When you have a sensational occurrence as happened this weekend, it certainly opens up the world to a whole new set of people.
Not all internet agencies measure traffic the same way, but they do agree. While NASA was making history on Mars, the web was making history of its own. Greg Lefebvre, CNN, San Francisco.
A NASA rover is sending some surprising data back from Mars. Coming up on Worldview, the latest on what scientists are learning from the Pathfinder mission. CNN's John Zarella is at the space agency's Jet Propulsion Laboratory in California, where the analysis is being done. John, the scientists are getting pretty excited today.
Boy, they certainly are. A major science briefing today here at JPL, and out of it, they've come to the conclusion that the sand on Mars from the two Viking sites and from this site all looks pretty uniform, at least the sand. They did some experiments with the rover. The rover is now over towards the Yogi. That's its next target, and then it'll be on to another rock called Casper. But here to talk to us about exactly how exciting the science was today is the project's chief scientist, Matt Golombek. And Matt, some fascinating revelations about the rock Barnacle Bill.
Yeah.
What is it?
Well, we don't know. We have this very good chemical composition measurement of the rock, but we're lacking sort of that high-resolution imaging to really look at the colors and textures and fabrics. And we desperately need that to really round out our interpretation. We don't know exactly how it formed, but we do know, and this is sort of the big news, that it's a high silica rock, which is a little bit different than what we thought Mars was like. We have the Snick meteorites, and they don't have a lot of silica in them. They tend to be more mafic, more basaltic. So this is a big deal.
So it means that Mars, in some of its characteristics, is more like what Earth was?
Yeah, that's right. If you consider sort of the Earth as sort of the active member and Moon is sort of the inactive member, it looks like the processes going on Mars are a little bit more like the Earth.
This is that panoramic
This is the middle part of what we affectionately call the monster pan, and the imager's deployed in its upright configuration, as tall as I am. You see the rover, and in the back there is the Yogi rock that we're up close to. And we've done soil mechanics in the soil flat between where the rover is now in this scene and Yogi Rock.
And you have there is a movie that you put together that sort of shows the rover mechanics.
Shows the rover as it turned around and went towards Yogi Rock. There's the rover turning around. You see the wheels completely turned. That's the Acumen steering, and it's turned pretty much around. And there is another picture of it after it's dug a hole in the soil. And I think you might have the final rotor picture that shows the APXS against the ground. And so we'll get another soil measurement tonight.
And then there's that last shot. We understand the soil is actually pretty hard, almost concrete-like.
Yeah, there's some kind of a material there that looks like it's indurated or something. There's Yogi, and we were a little worried about going right in there because there's a little moat and the rover might tip down a bit. So we're going to try to crab sideways. We can actually move sideways with the rover and try to get around to the side of the rock.
Matthew Golombek, I know some fascinating science still coming out here. The history of Mars unfolding before the very eyes of an excited group of scientists. This is John Zarrella reporting live from the Jet Propulsion Laboratory. Judy?
All right, John, fascinating stuff.
Barnacle Bill went through hell. That's how scientists are characterizing the rock star's history. It was probably blown from a volcano billions of years ago, deposited on the surface, buried over the ages, blown back to the surface by a meteor impact, and...
The implication is this rock was carried down in this massive flood and probably represents some of the highlands on Mars, the really ancient rocks.
All that in about 3.5 billion years or so. Barnacle Bill, the first rock analyzed by the Sojourner rover, has turned the science team on its head.
The whole project went so smooth so far that many people might have been taken to believe that this is a hoax. There was a film made many years ago, I think it was called Capricorn, where NASA was putting up state. Well, we can assure you it's not a hoax. We are on Mars.
A planet that shocked scientists say has more in common with Earth than they ever imagined.
I think that Mars, like the Earth, has been volcanically active basically throughout its history.
But the jury is still out on Barnacle Bill's origins. The chemical analysis has left it unclear whether Bill is volcanic or something else.
If this rock is a volcanic rock, then we would call it an andesite. It is also possible that it is not an igneous rock. It is not a lava. We are not sure yet.
The imaging team released the first pieces of the mosaic that will be the Monster Pan, a 360-degree color look at the landscape. And the science team revealed that sand on Mars appears to be the same all over. Samples from the Viking landers 20 years ago are nearly identical to this site. Soil analysis tests done by Sojourner also indicate Mars may have crustal features like the Earth. Sojourner is now positioned near its second target, Yogi. In the next couple of days, scientists hope to have close-up pictures of Barnacle Bill and the chemical analysis of Yogi. Then it's off to Sojourner's third target, Casper, just a few meters away. John Zarrella, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
The rover crawls over a Martian surface. Its cameras capture the landscape and send back images. A world away, an operator tries to guide the robot by looking at TV pictures.
What are you trying to do?
Get on top of that hill.
Why is that difficult?
Whoa. Because this doesn't go very fast.
Vince McLean learns the difficulties of exploring a distant planet by remote control. But Space Camp also teaches the trainees here they can overcome the difficulties with teamwork.
I mean, it was really hard work to actually get it on Mars because, I mean, it took a lot of planning and technology and, like, smarts and stuff.
About a year ago, I thought it would be impossible for them to make a civilization on Mars, and now it seems possible.
A Martian landscape and rover have been standard equipment at Space Camp well before Pathfinder ever left for Mars. Now Pathfinder's pictures give it life.
And it's like really interesting because I'm alive and I can see it.
I think that it's kind of interesting how this might be just another Earth if they figure out how, like, people could live here, like grow plants.
And someday I want to go there too, and so I think it's really neat that we can now send things there.
What do you mean you want to go there?
I want to be an astronaut and go to Mars someday.
You think that's ever going to happen?
Yeah.
How hard can it be? You put something up there, you drive around, you take some pictures. What's the big deal?
That they got Congress to accept it.
Between launches at Berkeley's Lawrence Hall of Science rocket camp, students watch NASA Mars pictures.
I kind of think it might be neater, though, if there were people there, because then they would, like, tell you what it's like.
You've seen all these movies, War of the Worlds,
all those movies about the aliens coming from Mars, so see there's nothing there, so you don't have to believe those movies.
Pictures from Mars, the excitement of discovery, and perhaps the inspiration for tomorrow's scientists. Don Knapp, CNN, San Francisco.
Latest on the Mars Pathfinder mission, let's join a NASA briefing that's going on.
It's about 6:30 p.m. Pacific Daylight Time, which is primarily the early morning on Mars, and the idea is to get the health of the spacecraft. So we'll just bleep down enough information that tells us that the spacecraft and the rover are all healthy, and then we'll wait till 10 p.m. to 1:30 a.m., I guess that's tomorrow, for another 3-hour session of high-gain downlink at 85 kilobits per second. Sorry, 8.5, sorry. 85 megabits per second. A total data volume. Excuse me. A total data volume of 85 megabits at 8,500 bits per second. I got it. We expect to take a variety of things with the rover today, and I'll describe those in just a second. A whole variety of imaging experiments, spectral spots, opacity measurements of the atmosphere, water vapor, sunrise and sunset measurements, and a series of the magnetic targets. The rover retracted the APXS from the soil. It moved. It did a weigh experiment, a wheel abrasion experiment. It moved slightly to the left to get a better view of Yogi. It imaged Yogi from the front cameras, and then it turned around and it imaged the lander from the front cameras, and it imaged Yogi from the rear cameras, and from that we've decided what to do next. So let me start with the first graphic. This shows, just for reference, okay, there we go. There's roughly where the rover was, I guess that was 2 days ago. We moved up here and imaged Yogi up close yesterday, and then the idea was to crab sideways and get an image of this face of Yogi to try to get a better place to put the alpha proton X-ray spectrometer. So the rover, what I'll show you next in the rover movie, is it crabbing sideways using the Acumen steering of its wheels. Show the video, please. There you see the outer wheels moving in their manner to crab sideways and turn slightly to get a better view of the portion of Yogi that we hope to put the alpha proton X-ray spectrometer against. Okay. Next graphic, please. This is a view from the front of the rover stereo cameras. Here you see the place that we dug a hole using the front wheel, and how we used the rover as sort of a bulldozer to push this rock here and this crusty material. And this is kind of like a little thrust fault where we pushed this up and it's ramped up a bit. Here shows you the full extent of Yogi rock with the interesting textures on it. And from this, we've gathered that there is a location over here that looks acceptable for attempting to place the alpha proton X-ray spectrometer against, and that's what we will be uplinking starting at about 6:30 this evening. Next one. Here is the picture of the lander sitting on the surface of Mars from the forward rover cameras. This completes the mission success criteria of the rover. It's clear that we're on Mars, guys. You can see just how large these airbags are and how they are sort of billowing out here, but at no hazard to the lander whatsoever. And here's our racetrack, the ramps for coming down off the lander. Next one. And finally, here's the end-of-day rover image that shows the vehicle after it has crabbed sideways, done all these turns, taken the image backwards, and it has placed the alpha proton X-ray spectrometer right here down against the soil, and it's been making that measurement through the night and is making it right now. And so tomorrow we should have results of the last 2 days of APXS measurements of the soil, and hopefully we will be able to get Yogi up, the rover up against Yogi. And finally, the last one, just for an abbreviated weather report on Mars, pretty much looks like it did yesterday. The pressure is rising, barometer rising just a wee bit at 6.77 millibars. Temperature a chilly -1 Fahrenheit. I guess that's Fargo, North Dakota. And winds light from the west. And stay tuned for tomorrow for our next weather report. With that, I hand it over to Jeff.
Okay, if we could go to the first graphic I have. Over the past couple days, Barnacle Bill has received a lot of attention because it was the first rock to be analyzed by the APXS instrument. The data from that instrument showed that Barnacle Bill's composition was consistent with the volcanic andesite, but the rough texture of the surface suggested to some of the folks that are working on it that the rock might be a mixture of rock fragments, which is generically termed a breccia. The question we wanted to investigate was, could the rock in fact be composed of many different rock fragments that combine to give a similar overall composition to what the APXS saw? What we'd like to do is take our opportunities of highest resolution all geology filters, which we call multispectral spots, little 64 by 64 picture element areas at the highest resolution we can get, target it on the rock, and try and see how that can help us determine the composition of the rock using a different method. We can go to the next graphic. What we're going to try to do is determine how variable, how different the reflectance spectra are across the face of the rock. Reflectance spectra in the visible wavelengths and the near-infrared wavelengths, which give us an idea of the mineralogy of the surface that we're looking at. Now, if we go across the rock and look at different parts of the rock and everything looks similar, the rock's homogeneous, that is, it's composed of basically the same material. If the spectra vary appreciably over the surface at different positions, we can consider the rock is heterogeneous, and this would be more consistent with the rock being composed of many rock fragments, such as an impact melt breccia, something that happens when an impact event occurs on the surface and rocks are fractured and melted and then recongealed when they come back to the surface. Or perhaps a conglomerate, which is a sedimentary rock that's formed by fluvial activity and deposition of materials that have been eroded and then deposited by flowing water. Let's go to the next graphic. This is a little cut off, but we can see Barnacle Bill down here, and then a bit grainy when it's blown up, but these are our multispectral spots right here. So this is the edge of Barnacle Bill, and what we're going to do is take a look at different areas on Barnacle Bill. These are color-coded such that the green area behind here is a little bit of the soil that's poking out. This is right at the edge of Barnacle Bill down here. The red areas correspond to what we're interpreting as a soil-like material that has been deposited in little crevices within the rock down through here. And in the blue, we're trying to extract areas that are basically a rock face that isn't covered with as much of this soil-like deposit. So when we look at the reflectance spectra, we'll go to the next graphic. And one more after that,
And the
please.
very latest there from NASA on the adventures of the rover Sojourner and the data that she is sending back to Earth. A lot of very technical information about rocks that Sojourner has been inspecting and letting us know that there will be more data coming down very, very shortly. Well, now back to Earth here. We'll be coming back in a moment with the very latest from the NATO summit in Madrid. Stay with us.
Es gibt Berge zu sehen im Hintergrund. Zwei von ihnen hat man schon benannt. Twin Peaks heißen sie. Man wünschte sich, Pathfinder oder vielmehr der Roboter könnte dorthin fahren, um sie zu untersuchen. Aber sie sind ungefähr 30, 40 Kilometer entfernt. Deswegen kann die Sonde nicht dahin. Man hat eingebaut in diese Einspielbilder eine Luftaufnahme vom Mars, die von Vikingen vor 21 Jahren geschossen wurde. Diese Luftaufnahme zeigt einen Krater und genau diesen Krater kann man im Hintergrund auf den Bildern sehen. Er ist nur sehr niedrig Oberfläche, aber wenn man oben hineinschaut, dann sind es mehrere hundert Meter, die er tief ist. Und die Wissenschaftler würden auch diesen Krater sehr, sehr gerne untersuchen, um herauszufinden, was hat sich da vor Milliarden von Jahren darin getan. Man ist ja jetzt schon sicher, dass dieses Gelände, auf dem Pathfinder gelandet ist, ein riesiges Meer war, dass es ein Grabenbruch war, durch den unendlich viel Wasser geflossen ist, so viel Wasser, wie es im Mittelmeer gibt. Und auf den letzten Bildern noch einmal der kleine Roboter, der wie er rangiert. Er wird eine neue Position einnehmen, um in der nächsten Nacht dann einen neuen Stein anzufahren, um ihn zu untersuchen. Und das hier ist ein Modell dieses Roboters, der da oben 200 Millionen Kilometer von der Erde entfernt auf dem Mars herumfährt. Er kann 45 Meter pro Stunde zurücklegen und wird ja, von Stein zu Stein sich bewegen. Und sie hoffen, dass er möglicherweise noch einige Kilometer sich von der Station, die hier im Hintergrund aufgebaut ist, entfernen kann, um dann noch weitere Daten zur Erde zurückzufunken. Der NASA hat dieses Unternehmen, der Erfolg dieses Unternehmens, einen unglaublichen Auftrieb gegeben. Die Amerikaner sind begeistert, vor allen Dingen die Amerikaner, die sich für Raumfahrt interessieren. Pasadena hier ist zu einer kleinen Pilgerstätte geworden. Es kommen tagtäglich Menschen her mit Kindern, die das Ganze sich anschauen wollen. Und die NASA hofft jetzt, dass sie schon in wenigen Jahren für 20 Milliarden Dollar eine bemannte Mission auf den Mars schicken kann, dass es dafür dann auch Geld gibt, ob von Unternehmen oder vom Steuerzahler, das weiß man nicht. Wie sehr die NASA in der Lage ist, Geld zu akquirieren, das berichtet Sabine Reifenberg.
Computeranimation der NASA. Die Abenteuer der Pathfinder-Sonde und ihres Mini-Passagiers. Ein Roboter wird vermenschlicht. Kuss heißt dieses Bild. Die perfekte Show fing im Sandkasten an und läuft seitdem wie am Schnürchen weiter. Gut für die NASA. Die Mission bewegt unsere Herzen. Wir Amerikaner sind Forschungsreisende. Das wissenschaftliche Neuland liegt jetzt hinter dem Mond und dem Mars und den anderen Planeten. Neuland, das vom amerikanischen Steuerzahler finanziert werden muss. NASAs Marsfieber steckt die Nation zwar an, doch nach wie vor gilt in den USA, weniger ist mehr, vor allem für Raumfahrtprojekte. Das ist die Mehrheitsmeinung im amerikanischen Kongress, dem Geldgeber. Pathfinder beweist uns, dass es überflüssig ist, Milliarden Dollar dafür auszugeben, Menschen auf den Mars zu schicken. Roboter erledigen doch die Arbeit zu 90%. Das ist besser und billiger als die bemannte Raumfahrt. Roboter, nicht Menschen im All, dieser Ansatz überzeugt auch Kritiker der NASA. Jetzt, dank der Roboter, sehe ich wieder eine große Zukunft für die Weltraumforschung. Das nächste Schiff der Mars-Flotte nähert sich bereits dem roten Planeten, vom US-Kongress voll finanziert. Im Spätherbst diesen Jahres soll Global Surveyor die Oberfläche des Mars abtasten, um davon eine genaue Karte zu zeichnen. Bis 2005 sind insgesamt 10 Robotermissionen geplant. Bislang sind die Amerikaner bereit, pro Jahr 14 Milliarden Dollar in die Raumfahrt zu stecken. Kritik wächst allerdings an der Zusammenarbeit mit den Russen auf der defekten Raumstation Mir. Die Attacken in den Talkshows wachsen. Ist der amerikanische Astronaut auf der Mir gefährdet? Sicherheit ist unser oberstes Gebot. Wir arbeiten mit den Russen da eng zusammen. Die Unterstützung für das Mir-Projekt sinkt allerdings in den USA und damit auch der Wille, Milliarden Dollar in die bemannte Raumfahrt fließen zu lassen.
Wenn einer für sich in Anspruch nehmen darf, als erster Lebewesen auf dem Planeten Mars entdeckt zu haben, dann ist das ein kleines Gefährt auf 4 Rädern. Gerade mal Schuhkarton groß liefert es die Bilder, die wir Ihnen heute in unserer Sendung zeigen können. Was in dem kleinen Marsmobil steckt, weiß Anabel Bermejo.
Sie freuen sich wie die Kinder. Kein Wunder, denn schließlich ist ihnen eine kleine Sensation gelungen. Das ferngesteuerte Marsmobil Sojourner beginnt nach anfänglichen Anlaufschwierigkeiten seine Erkundungsfahrt auf dem Mars. In jedem Wissenschaftler der US-Raumfahrtbehörde NASA steckt anscheinend auch ein Kind. Denn die Mission Pathfinder wirkt bisweilen wie eine wahr gewordene Jugendfantasie, die Erkundung fremder Welten. Der Sojourner ist eben nur ausgefallener als ein herkömmliches Modellauto.
Ich war an der Entwicklung der Räder beteiligt. Damit hinterlasse ich meine Spuren auf dem Mars.
Wie bei einem virtuellen Computerspiel simulieren die Raumfahrtexperten in Pasadena die Erkundungsfahrt des Elektromobils auf dem Mars. Auch wenn Joystick und 3D-Brille wesentlich ausgefeilter als das Spielzeug zu Hause sind. Die Begeisterung der Wissenschaftler kennt keine Grenzen.
Hier der Beweis, wie Sojourner den Marsstein Barnacle Bill leidenschaftlich küsst.
Die Marssteine werden auch nicht nach wissenschaftlichen Gesichtspunkten benannt, sondern nach Comicfiguren. Goofy, Scooby-Doo, Yogi. Jedes Kind in den USA kennt diese Namen. Doch auch bei allem Eifer verliert man das Forschungsziel nicht aus den Augen.
Am Ende des Tages haben wir ein Vollbild vor dem Roboterauge. Ganz nah. So wollen Geologen darauf schauen. Schön nah, damit wir genau sehen, was wir da haben.
Doch selbst seriöse Geologen wird es sicherlich wundern, dass ein sonst so staubiges Thema jetzt Menschenmassen begeistert.
Zu Gast bei uns im Studio Ernst Hauber vom Institut für Planetenerkundung der Deutschen Forschungsanstalt für Luft- und Raumfahrt, ein langer Titel, und das residiert hier in Berlin-Adlershof. 2 seiner Kollegen sind in Pasadena. Herzlich willkommen bei uns in Berlin.
Vielen Dank.
Beneiden Sie Ihre Kollegen in Pasadena?
Ja, natürlich. Es wäre eine einmalige Chance, live bei einer soeben gelandeten Mars-Mission dabei zu sein. Danach sehnt sich wahrscheinlich jeder Wissenschaftler.
Wir haben es gerade in Bildern gesehen, es ist ja doch eine recht trockene, staubige Angelegenheit. Trotzdem soll dort mal Wasser gewesen sein. Wo ist das ganze Wasser hin?
Darüber gibt es mehrere Theorien. Die derzeit gängigste ist, dass das Wasser, ähnlich wie in Sibirien, als Permafrost unter der Erdoberfläche noch in einer mächtigen Eisschicht vorhanden ist.
Wo es Wasser gibt, müsste es ja nun eigentlich auch Leben geben. Wie wahrscheinlich, glauben Sie, ist die Möglichkeit?
Man weiß, dass früher auf dem Mars Verhältnisse waren, die der Erde sehr viel ähnlicher waren, sehr viel wärmer, sehr viel feuchter. Es hätte also dort durchaus Leben entstehen können. Ob dieses Leben immer noch existiert, das sei dahingestellt. Wir haben es bis jetzt noch nicht nachweisen können. Die jetzige Mission wird darüber auch keinen Aufschluss geben. Aber in der Zukunft, wenn man vielleicht in der Lage ist, den Untergrund anzubohren oder zu graben, wird man mehr wissen.
Also Sie glauben, dass man in diesen Gesteinsbrocken oder Untersuchungen jetzt noch nicht feststellen kann, ob dort, sagen wir mal, Kleinstlebewesen da waren oder sind?
Nein, dafür ist diese Sonde nicht ausgestattet. Die ist von vornherein für andere Zwecke konzipiert. Die Erforschung von Leben gehört nicht zu den Zielen dieser Mission.
Sie sagen, es war dort früher viel wärmer, auch viel feuchter. Wie kam dieser Klimaumschwung zustande?
Man geht davon aus, dass die Atmosphäre dünner geworden ist. Das könnte dadurch hervorgerufen sein, dass ein Teil der Atmosphäre in den Weltraum langsam wegdiffundiert ist, entkommen ist. Ein anderer Teil ist wahrscheinlich ausgewaschen worden durch Regen, auch als es noch Wasser gab, durch das Wasser gebunden worden. Dadurch hat sich der Treibhauseffekt erniedrigt und die Temperaturen gingen stark zurück. Und das wiederum, also als Art Rückkopplungseffekt, hat dazu geführt, dass Wasser jetzt nicht mehr in flüssiger Form an der Oberfläche stabil ist.
Also wenn ich das mal als Amateur ausdrücken darf, war es quasi die Umkehrung des Treibhauseffektes, den wir hier auf der Erde haben?
So kann man sagen, ja. Die Atmosphäre hat sich dort selbst abgebaut und der Treibhauseffekt ist verschwunden.
Nun gibt es ja ein paar, ich möchte nicht sagen Phantasten, vielleicht sagen wir Idealisten, die sagen, irgendwann wird auch auf dem Mars Leben möglich sein.
Es gibt einen Zweig der Wissenschaft, ob man ihn jetzt völlig ernst nehmen soll oder nicht, sei dahingestellt, der sich mit dem Begriff des Terraforming befasst. Also könnte man aus dem Mars wieder etwas wie die Erde machen, indem man Elemente, die dort vorhanden sind, in eine Atmosphäre umwandelt und dadurch diesen Effekt wieder hervorruft, den Treibhauseffekt auf dem Mars. Dort wäre er ja für die Zwecke der menschlichen Besiedlung erwünscht. Aber es sollte in absehbarer Zukunft nicht ernsthaft darüber nachgedacht werden. Es ist einfach nur technologische Spekulation.
Ich danke Ihnen, dass Sie da waren.
Bitte sehr.
Nicht nur in Pasadena wird gejubelt, auch Wissenschaftler aus Deutschland dürfen sich auf die Schulter klopfen. Das wichtigste Messgerät an Bord von Pathfinder ist ein sogenanntes Spektrometer. Es analysiert die Gesteins- und Bodenproben. Das Gerät wurde mit Hilfe des Max-Planck-Instituts in Mainz entwickelt. Nicole Schneider war dort.
Sie sieht unscheinbar aus und ist nicht viel größer als ein 5-Mark-Stück, die eigentliche Spürnase des Erkundungsmobils Sojourner. Die genaue Bezeichnung Alpha-Proton-Röntgenspektrometer APXS. Aufgabe des Apparates ist es, die chemische Zusammensetzung von Bodenproben zu bestimmen. Der Sensorkopf befindet sich am hinteren Ende des Marsmobils und stöbert die Proben auf. Anschließend gibt er die gefundenen Elemente an diesen kleinen Kasten, das Gehirn des Spektrometers, weiter, der die Daten analysiert.
Der Messkopf sendet Alphastrahlen aus, also Teilchenstrahlen, und die stellen in der Probe alles Mögliche an. Zum Teil werden sie zurückgestreut, zum Teil machen sie Kernreaktionen, liefern Protonen, aber sie liefern auch Röntgenstrahlung durch Wechselwirkung der Alpha-Teilchen mit der Atomhülle der einzelnen Elemente in der Probe. Und all das wird, die Energieverteilung all dieser zurückkommenden Strahlung wird gemessen und daraus entnimmt man die chemische Zusammensetzung, die Häufigkeit der verschiedenen Elemente in dem Stein oder in dem Boden.
Fast 10 Jahre haben die Wissenschaftler des Max-Planck-Institutes an ihrem Spektrometer gearbeitet. Gesamtkosten rund 4 Millionen Mark. Zwar hat es schon andere Spürnasen gegeben, aber bislang war es nicht möglich, größere Gesteinsproben vor Ort zu analysieren.
Das geht eigentlich nur einfach mit unserem Gerät, weil das man einfach nur an den Stein ranhalten muss und einschalten und dann kriegt man die chemische Zusammensetzung. Allerdings, man muss so etwa 10 Stunden lang messen. Messen tun wir während der Nacht, wo der Rover ohnehin nicht fahren kann und wo es kalt genug ist, dass die Spektrometerkristalle funktionieren.
Auch wenn die Entwicklung APXS allgemein als voller Erfolg gewertet wird, in Mainz denkt man bereits über eine modifizierte Version nach. Das nächste Marsmobil, das den roten Planeten erkunden soll, wird wesentlich kleiner sein. Das Spektrometer muss also noch um einiges abspecken, damit es wieder mitfliegen darf.
Ulf Merbold sitzt an Bord unseres Bonner Studios. Er war ESA-Astronaut und zweiter Deutscher im All. Guten Abend.
Ja, schönen guten Abend.
Herr Merbold, beneiden Sie das kleine Marsmobil?
Ach ja, ich meine, jeder möchte natürlich gern den Mars mal aus der Nähe sehen. Aber beneiden kann ich nicht sagen. Das ist ja sozusagen die logische Vorbereitung dafür, dass irgendwann mal Astronauten dahin fliegen können.
Könnten Sie sich für sich selbst einen bemannten Flug zum Mars vorstellen?
Ja, durchaus. Allerdings muss man auch Realist sein. Und ich denke, wir werden schon noch etwa 20 Jahre brauchen. Bis dahin bin ich dann zu alt.
Ja. Unter welchen psychischen und auch körperlichen Belastungen würde denn so ein Flug stattfinden?
Ja, er wäre mit der heutigen Technologie durchaus möglich. Das heißt mit den chemischen Raketenmotoren, würde aber zwischen 2 und 3 Jahre Zeit kosten, um hin und zurück zu fliegen. Und das ist natürlich psychologisch auch eine schwierige Herausforderung, sich einer solchen langen Zeit einer Maschine sozusagen auszusetzen. Denn als Astronaut kann man im Weltraum nur so lange überleben, wie die ganze Maschinerie um einen herum auch funktioniert.
Mal ganz praktisch gesehen, so ein Flug würde ja allein 6 Monate für den Hinweg in Anspruch nehmen. Was passiert da im Körper?
Ja, man passt sich relativ schnell an diesen Zustand der Schwerelosigkeit oder wie wir heutzutage genauer sagen, Mikrogravitation an. Und dann fühlt man sich sehr wohl. 6 Monate, das ist im Grunde schon der Schnee vom letzten Winter. Ich bin auf der Raumstation Mir mit Valeri Poljakow geflogen. Der ist auf dieser Mission allein 438 Tage im Weltraum gewesen. Das sind im Grunde 3 mal 6 Monate.
Was passiert dann, wenn man wieder zu Hause ankommt?
Dann ist es ungefähr so, als würde man nach langer Krankheit zum ersten Mal wieder aufrecht stehen, sich aus dem Bett aufrichten. Man fühlt sich etwas wackelig auf den Beinen, aber in ein paar Tagen ist eigentlich schon wieder alles beim Alten. Und natürlich hat man bei diesen Leuten, Poljakow und anderen, die lange im Weltraum waren, nun auch sehr sorgfältig geschaut, ob da irgendwelche Spätfolgen eintreten. Das ist nicht der Fall.
Also ich kann mir ja die Sehnsucht danach vorstellen, den Mars einmal betreten zu wollen. Aber welchen Sinn macht es denn eigentlich dort, Menschen hochzuschicken?
Ja, da können Sie genauso fragen, welchen Sinn macht es, Menschen nach Antarktika zu schicken oder in die Wüste? Es ist eben einfach in unserer Erdmasse einprogrammiert, dass wir nicht anhalten, sondern jede Position, die unbesetzt war, in dem Moment auch besetzen, wo es technisch geht. Und damit haben wir doch sicher die Erfahrungshorizonte in der Vergangenheit zumindest mal beständig verschoben, immer wieder neue Erkenntnisse hinzugewonnen. Ich kann ja nicht wissen, welche neuen Einsichten auf dem Mars auf uns zukommen werden. Ich kann nur sagen, in dem Moment, wo wir nicht hingehen, haben wir uns von Anfang an davon abgekoppelt, ausgeschlossen, was Neues zu lernen.
Die grünen Marsmännchen stehen jedenfalls offenbar nicht mehr auf dem Programm.
Ja, ich wäre sowieso eher an den grünen Marsmädchen interessiert, aber ich befürchte, nach allem, was eben die Proben, also zum Beispiel Pathfinder, an Erkenntnis bis jetzt geliefert haben, ist das nicht zu hoffen.
Na, vielleicht, wir werden es ja noch sehen und vielleicht spielt dann das Alter auch keine Rolle. Vielen Dank, Ulf Merbold nach Bonn. Der Wettlauf im All ist auch immer ein Wettlauf um Kosten. Hauptläufer sind dabei nach wie vor Russland und die USA. Am 4. Juli, dem amerikanischen Unabhängigkeitstag und dem Tag, an dem die Raumfähre der Amerikaner auf dem Mars landete, gab es bei einigen Wissenschaftlern in Russland lange Gesichter. Nicht, dass sie ihren Kollegen den Erfolg nicht gönnen würden, aber auch in Moskau hatte man bereits jahrelang eine solche Mission vorbereitet. Karin Lukas berichtet.
Professor Vyacheslav Linkin hat sich dem Mars verschrieben. Seit Jahren erprobt er mit seinen Mitarbeitern dieses Raumfahrzeug, dem sich praktisch nichts in den Weg stellen soll, egal wie steinig die Oberfläche des roten Planeten auch ist. Die gescheiterte Mars-Mission 96 hat bei den Wissenschaftlern große Enttäuschung ausgelöst. Jahrelang hatten sie das 2-Milliarden-Projekt vorbereitet. Wir haben nur sehr wenig Hoffnung, dass noch einmal ein Mars-Raumschiff wie Mars 96 starten wird oder etwas in der Größenordnung. Nicht nur in seinem Forschungsinstitut herrscht Finanznot, die Geldsorgen sind schuld daran, dass der Ruhm sowjetischer Raumfahrt in Russland mittlerweile verblasst ist. Was den Mars betrifft, waren die Russen allerdings auch schon zu Sowjetzeiten vom Pech verfolgt. Von insgesamt 17 gestarteten Missionen ist lediglich eine vollständig geglückt. Doch die Wissenschaftler geben den Wettlauf mit den Amerikanern nicht auf. Ihr neues Raumfahrzeug ist startbereit. Wir waren schließlich die Ersten, die die Marsoberfläche berührt haben. Dadurch haben wir erfahren, dass es auf dem Planeten ausgetrocknete Flussbetten gibt. Es gab also früher Wasser, jetzt gibt es keins. Das Klima ist grausam. Die gescheiterte 96er-Mission sollte die Oberfläche des Mars erkunden und Aufschluss über mögliche Spuren früheren Lebens bringen. Daraus wurde nichts. Und so machen die Russen in den letzten Jahren ihren Erfolg vor allem an ihrer Raumstation Mir fest. Doch auch die sorgt mittlerweile nur noch für Negativschlagzeilen. Eine Panne folgt der nächsten. Kein Wunder, sie ist mittlerweile 11 Jahre alt und sollte längst ausgedient haben. Die letzte große Sensation der Russen war der Raumgleiter Buran. Dessen Jungfernflug 1988 ist allerdings der einzige geblieben. Nicht verwunderlich, die Ausgaben für die Raumfahrt wurden im Vergleich zu Sowjetzeiten auf ein 1/5 zusammengestrichen. Der Professor erzählt, dass die Spezialisten für die Teilnahme am Prestigeprojekt Mars 96 eine Art doppeltes Gehalt bekamen, eine halbe Million Rubel. Das sind nicht einmal $100 im Monat. Trotz all der Sorgen erhält er sich seine Leidenschaft für den roten Planeten. Im nächsten Jahrtausend soll das Raumfahrzeug des Instituts den Mars erkunden. Früher wird es wohl nichts, auch wenn Vyacheslav Linkin durchgerechnet hat. Wenn wir den Flug Mars 96 wiederholen würden, dann würde das nur ungefähr 1/3 der Kosten gegenüber dem ersten Versuch bedeuten. Die ganzen Erfahrungen, die wir gesammelt haben, sind ja nicht verloren gegangen. Sie machen 2/3 der Kosten aus. Der Wettlauf der Russen mit den Amerikanern wird weitergehen, auch wenn der Mars es ihnen nicht einfach macht, wenn es darum geht, seine Geheimnisse preiszugeben.
Wie waren denn die letzten Minuten oben auf dem Mars? Was hat sich getan?
Der Rover hat also eine Gesteinsuntersuchung gemacht von dem Barnacle Bill und ist dann also ein Stück weitergefahren. Und es sind zum ersten Mal Und das ist das Letzte, was noch nicht versucht worden ist, die Kameras von dem Rover in Betrieb genommen worden. Der hat also auch vorne 2 kleine Kameras und kann also ganz dicht am Gestein
Sind die auch zum Teil
machen.
von Ihnen gebaut?
Die sind nicht von uns gebaut worden.
Was sehen wir da jetzt?
Hier sieht man, wie der Rover durch Bewegungen der Räder versucht, die Festigkeit von dem Boden auszuprobieren. Also so wie man im Schnee stecken bleibt, so kann man durch dieses Durchdrehen der Räder sehen, wie der Boden beschaffen ist. Da sehen wir jetzt hinten am Horizont so einen flachen Hügel. Der Horizont, der ist so ungefähr 4 Kilometer weg. Dieser flache Hügel ist dieser Krater, der jetzt unter dem Pfeil zu sehen war. Und unsere Sonne ist etwas drüber gelandet.
Und das sind Bilder, die praktisch gerade eben erst angekommen sind. Wie lange brauchen die vom Mars?
Die brauchen ungefähr 10 Minuten, bis die hier sind.
Und das ist jetzt eine Aufnahme von dem Rover, von der Kamera von dem Rover. Und die guckt sich also den Länder an. Und man sieht nur einen Teil von dem Länder, weil der obere Teil völlig überbelichtet ist. Da ist also alles weg. Man sieht vorne noch die Rampe zum Herunterfahren.
Hier sieht man oben, dass der Stein, den der untersucht hat, eine sogenannte Brektie ist. Das kennen die Leute, die im Nördlinger Ries wohnen. Da sind also viele einzelne Gesteinsklumpen zusammengebacken. Das heißt, da sind ein Krater in der Nähe.
Das sehen Sie alles von der Optik oder haben die das alles so schön erklärt?
Beides.
Das ist hier eine Aufnahme von Yogi, von der Kamera von dem Rover, aus der unteren Perspektive heraus. Das ist ein runder Stein, der also durchs Wasser gewälzt worden ist. Der ist jetzt hier mit unserer Kamera zu sehen. Und jetzt noch mal so ein Rundschwenken. Da sieht man, dass hier also doch wesentlich mehr Auflösung. Und das ist eine Kamera, die eine wesentlich größere Auflösung hat als übliche Kameras. Deswegen kann man also die ganzen Details alle erkennen. Da ist also nichts davon überbelichtet. Hier ist ein Sonnenpedal und die Ballons, die zusammengefaltet sind, gucken darunter heraus. Hier sieht man die Rampe. Das ist aber nicht die, auf die der Rover heruntergefahren ist. Das ist die linke Rampe, die als Reserverampe diente. Hier ist dann wieder ein Sonnenpedal. Der Rover hätte das zugedeckt und dann wäre kein Sonnenlicht gekommen, wenn er da drauf gekommen wäre.
Kein Leguan gesichtet?
Noch nicht. Vielleicht müssen wir noch so einen Stein umdrehen, ne?
Wir fliegen ja in 2 Jahren schon wieder dahin und da haben wir vielleicht eine Chance, einen zu sehen.
Wie lange werden jetzt immer neue Bilder noch produziert und kommen hier an auf der Erde?
Also die nominelle Missionsdauer ist 30 Tage. Aber es spricht eigentlich nichts dagegen, wenn alles hält, dass man auch länger macht. Also man kann sich durchaus vorstellen, dass wir noch einige Monate Bilder kriegen werden.
Wird man dann mutiger, dass zum Beispiel dieses Auto dann weiterfährt, die Kamera sich weiter wegbewegt, aber dass natürlich dann auch mehr passieren kann?
Ja, da geht man natürlich ein Risiko ein. Aber mit einem Risiko kann man natürlich auch wieder was gewinnen. Das muss man ja auch sehen. Dass man eine Zeit auf der guten Seite liegt und durchaus Erkenntnisse bekommen kann, die man sonst nicht bekommen könnte.
Was könnte zum Beispiel für einen Fehler passieren, der irreparabel wäre?
Es könnte zum Beispiel passieren, dass der Rover hinter einem Hügel verschwindet, wo man den Kontakt mit ihm verliert und dann wäre er eventuell weg.
Ja, aber dann kann er doch wieder zurückfahren.
Da ist die Frage, wie viel Eigenintelligenz er hat. Also wir gucken ja immer mit unserer Kamera, wo er eigentlich ist. Nicht? Also man möchte ihn eigentlich immer in den Augen behalten, sozusagen.
Das verbraucht ja alles Strom. Den holen Sie sich von der Sonne?
Ja.
Richtig.
Und sind irgendwann trotzdem diese Batterien mal erschöpft oder könnte das im Grunde unendlich so weitergehen?
Nein, das könnte, man kann damit rechnen, dass irgendwann auf den Steinen, sagt man ja Staubpolster, dass die auch irgendwann durch Staub zugedeckt werden. Aber das würde ziemlich lange dauern. Es ist sehr viel Staub in der Luft. Deswegen sieht der Himmel bei den Farbbildern ja genauso aus wie der Boden, weil so viel Staub in der Luft ist, dass er also keine andere Farbe hat.
Wobei man es nie so, man sieht es nicht stauben so richtig, ne? Weil kein
Nein,
Wind da ist, oder?
Ja.
Und könnte dieses Auto theoretisch 2 Kilometer weit wegfahren?
Das denke ich schon, ja.
Es ist also geplant, dass es so ein paar 100 Meter weit fährt. Der fährt ja sehr langsam. Beim Rover ist das mehr ein technisches Problem. Da hat man Angst, dass die Elektronik irgendwann kaputt geht und deswegen kann man nicht so weit fahren.
Sitzen Sie jetzt jede Nacht da vor den entsprechenden Pressekonferenzen und machen bei jedem Bild A und O oder wird es für Sie auch irgendwann mal nicht mehr so spannend?
Also ich war in Pasadena in der Phase und da waren wir natürlich da. Das ging immer bis nachts um 1:30 und da kamen die wissenschaftlichen Konferenzen. Bloß hier ist es ein bisschen schwieriger, an die Daten heranzukommen. Also dann sitzen wir heute zum Beispiel hier und können dann also nur mal so nebenbei auf den Bildschirm schauen.
Hier ist ja schon gut, ich höre ja schon auf. Ja. Nein, vielen Dank, dass Sie gekommen sind und...
ja, ich wollte Ihnen noch was schenken. Wir haben also Stereobilder, die wir anschauen können und dazu benutzen wir diese Brillen.
Aber das ist jetzt keine Verarschung, ja, weil ich von Physik keine Ahnung habe hier. Stereobilder, das ist doch dieses Ding, was man immer, diese 3D-Brillen.
Ja, so wie aus dem Kino, und die brauchen Sie auch, wenn Sie die nächsten... Da können Sie die Bilder vom Mars dann in 3D sehen, wo Sie also richtig plastisch in die Bilder reinschauen.
Warum haben Sie das nicht gegeben, wo die Bilder eben da waren?
Das geht nicht vom Fernsehschirm.
Ach, nicht vom Fernseher, da geht's gar nicht.
Sie müssen dann entsprechende Bilder haben. Wir können Ihnen auch ein solches Bild geben. Und wenn Sie da einmal drauf geguckt haben, setzen Sie die Brille nie wieder ab.
Gut,
weil das so toll ist.
Das werde ich mir merken. In diesem Sinne mache ich jetzt eine kleine dreidimensionale Pause. Wir sind gleich wieder da. Vielen Dank.
There are quite a few ecstatic scientists poring over the latest data from the Mars Pathfinder mission. Our John Zarella joins us now from the U.S. Space Agency's Jet Propulsion Laboratory in Pasadena, California. John.
Good evening, Judy. Today, more spectacular pictures coming out at the afternoon briefing and more science released about the nature of Barnacle Bill, the first rock examined on Mars. Still, the question remains, what exactly is Barnacle Bill? Is Barnacle Bill a volcanic rock or perhaps something else? Scientists still not quite clear about that. But Matthew Golombek, the chief scientist here today, said, "Clearly, we're on Mars, guys." That was his quote in response to a picture that they released from the rover, taken from the rover Sojourner of the lander. You can see the landing craft there, the Pathfinder lander, the ramp down which Sojourner had to traverse. Turned out it was quite a steep angle, and to the left of the screen on the picture, the airbag material, still quite inflated. A good thing it did not cover up the lander, and everything worked well. They were able to get Sojourner off. Now, they also released a short movie showing Sojourner doing something that, of course, automobiles can't do. There it is, like a crab, turning by crabbing across the Martian surface. At one point, they also spun the wheels and dug into the Martian surface. You can actually see it digging in a little ways there as well. And one of the highlights, the Monster Pan, finally released today, 360 degrees. There's the rover Sojourner. There's Yogi, the big rock, as we pan left to right across the Martian landscape. This particular pan is made up of about 200 tile-shaped images that have come down over the past 3 or 4 days from the landing craft and back here to the Jet Propulsion Laboratory and the imaging processing facility here. The press conference also provided some light moments when one of the scientists on the team, Peter Smith, said that he's actually started to live on Martian time.
All right, I want to make a quick observation on the effects of shifting your schedule 37 minutes later every day to stay on Martian local solar time. When you say good morning as the sun is setting, now that's living on Martian solar time. When your sunglasses look like this, that's living on Martian time. When there's no time for laundry and you get your shirts out of the box of Project T-shirts every day, that's living on Martian solar time. When you start admiring strange-looking rocks, giving them names and talking about them to your friends, that's living on Martian time. When your days are called souls and your nights are called days, that's living on Martian time. But when you start laughing at the engineer's jokes, you know you're living on Martian time.
Joining us now to talk about living on Martian time, Dave Gruhl. And you're an engineer, and Peter Smith starts laughing at your jokes. You're on Martian time. I want to tell the folks out there that you are probably as responsible as anyone for the success of Pathfinder and the rover Sojourner on the surface, because you're the guy who provided the gremlins. Now, to have anything successful, you've got to provide problems for the scientists.
That's true.
So what did you do?
Well, one of the tasks we had to do is we spent a lot of time during the cruise phase of the mission testing out exactly what we were going to do on the surface. And my job in that whole picture of doing that stuff was to go into the sandbox, which is where we tested all of our stuff, and to throw abnormal situations to all the other engineers for them to try and figure out and to resolve using the data that they actually would be getting from the spacecraft. So when we actually got to the surface of Mars, they had a lot of stuff in their back pocket and a lot of experiences in their back pocket to allow them to be able to go around or get around any problem that they might see on the surface.
And one of the problems that they saw right off the bat was the airbag.
The airbag material in the way of the rover being deployed. That's one of the test cases we threw at them right from the start. And the minute I saw that come down from the surface, I knew it wasn't going to be a problem because we had tested it numerous times actually in our test environment to show them that they could actually do it by lifting the pedal up, sucking the airbag material in more, and putting the pedal back down. We could get around that, and the rover could get off successfully, and we could have a successful mission.
Dave, thank you very much for joining us. And all of the science team has told us that thanks to the work of Dave and throwing them those curves, they were able to figure out the problems and move on very quickly. We want to remind you, 3:30 Eastern Time tomorrow, the next of the NASA briefings, and of course on Friday night at 10 p.m. Eastern Time. You will not want to miss it. A 1-hour special. That's the Journey to the Red Planet, the little rover that could. And that promises to be a wonderful program. This is John Zarella reporting live from the Jet Propulsion Laboratory in Pasadena. Judy?
Fascinating stuff, especially watching the rover dig into the surface of Mars. Thank you, John.